everybody. Yes, the structure of atom, chemical bonding and periodic properties are the three chapters that we are going to discuss today. And guess what? I know, I understand that these are all written here, but what exactly is happening in this session? In this session, once we complete this, okay, so basically that means that if you stick to the session till the end, what are you going to get? You will be completing about 25% weightage of the whole chemistry paper. That means you will be able to solve 7 to 9 questions of your JEE paper, and that's a lot. And that's a lot, my dear student, isn't it? Plus, one more thing that is going to help you with is these chapters are the most basic, the most fundamental of class 11th and class 12th chemistry. That means these will also help you in preparation of the other chapters. So, hello everybody, very good afternoon and a warm welcome to Vedanta JEE English channel. This is your master teacher, Navomita Bhattacharjee, and let's start with our session. Everybody ready? Can I get some la 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 in the chat box? Yes. Today, these chapters are going to be easy peasy. Biryani is tasty. Yes. Amazing, amazing. I can see a huge response. And by the way, to all the students who are already here right on time, don't forget to like the session. Thank you so much for coming right on time. Yes. So let's begin, everybody. Chalo, let's begin. Yes. Now, the story of structure of atom, right? The atomic structure, the story of atomic structure not only started in this year, that is class 11, but it actually started when we were in our junior grades, when we were in our 9th standard or 10th standard. And that's when we studied that John Dalton, he came up with his own postulates, right? And what did he say? What did he say? He said few things. And he said that basically, an atom is indivisible. It was proven to be wrong later on, but at that time, it was a milestone. Yes, it was revolutionary. That idea that John Dalton came up with was revolutionary, isn't it? He also said that atom of one kind, yes, atom of one element will be similar, obviously. Look at all the oxygen atoms, they will be similar. Look at all the hydrogen atoms, they will be similar. Look at all the nitrogen atoms, they will be similar. And he also said that atoms of two different kinds will have differences, right? They are not going to be similar. So if you look at hydrogen and if you look at oxygen, yes, they are going to be different. Common sense? Yes. Now he also said that atoms, when they rearrange, right? When they rearrange in a reaction, they do that. Yes, and they also said that, and he also said that they react, they combine together in whole number ratio. Now, apart from here things started to change. Yes, later on it was found that actually no, atoms are not indivisible, but they have 3 subatomic particles, that is protons, neutrons and electrons. Yes, and these 3 were discovered by different people. Now, one fine day during Christmas time, Thomson, yes, Sir J.J. Thomson, he was eating a pudding. Yes, us Indians, we don't understand pudding so much because we don't eat it. We eat watermelon, right? So from here we saw, he thought that probably the red part in the watermelon can be called as the positive sphere, and the seeds of the watermelon, you know how you bite a watermelon? Like, you spit it out, right? You spit the seeds out, isn't it? So those seeds that were engraved in the watermelon, they were considered to be what? The electrons, yes. Now obviously that explained, yes, this model could explain the stability of the atom, but was it completely fine for us? No. And that's why we had to come up with newer models. So after Thomson came up, yes, this model is known as plum pudding model. It is also known as raisin pudding or watermelon. Again, Indians, right? We don't understand plum pudding because we have hardly eaten plum pudding, or we haven't eaten puddings. I mean, in general, we don't eat pudding. Yeah. We eat watermelon, muskmelon and all of these. So that's easier for us to understand. And what we're going to do is we are going to understand it as, where is the pen? Yeah. We're going to understand it as watermelon model, okay? So this is you can consider this to be the red part, and these electrons are engraved in it. Electrons can be considered as the seed. Now moving forward from plum pudding model, Rutherford did another experiment, and because of the Thomson's plum pudding model, what did he expect? He expected that whenever he bombarded the alpha particles, what are alpha particles, guys? What are alpha particles, everybody? Chalo, let's talk about alpha particles for 1 second. Alpha particles are basically He4, 2He4, okay? Atomic number 2, mass number 4. This is your alpha particles, yeah? Understanding? Easy peasy biryani is tasty, everyone. Till now, easy peasy biryani is tasty. Yes? Yeah, we are revving it up, guys. We're starting it with a story and starting it with little easy bar. Wait, hold on. 3 chapters, it's not going to be that easy, yeah? 3 chapters is not going to be that easy. And yes, I want to keep the explanation easy so that at the end of the session, it does not go like, woo! No bouncers. Everything has to go here. Right? Clinical clear? Till now, everything is clinically clear. Can I have some thumbs up? Fire? Anything? Yeah? Amazing. Okay. All right. You had biryani and I feel sleepy. No, I want you to keep writing then, okay? Easy peasy biryani is tasty. Don't feel sleep. Also, call up your friends, guys. What is happening? Call up your friends, everybody. Let's start with it. Awesome. Now I can see more students coming in. Also, the likes are very less. Why? Huh? Have I done something to you? Huh? You guys are not liking me? Do hit the like button, yeah? A little bit of support for me also. I didn't have lunch also. I'm going to have lunch only after the session. So no lunch. I'm going to have evening snacks directly. So hello. No support for me? Yeah. All right. Just for 5 minutes I should wait, huh? Okay. I still see less number of students, guys. I don't know why. Chemistry is over for you. Everybody is done with chemistry. Josh is high. Awesome. Start prepare for G. What am I doing? Dancing? No. This is a class for JEE only. Okay. So coming to Rutherford's experiment now. So Rutherford, from the Thomson's model, he thought that when he will be bombarding the alpha particles, he thought that it will all get deviated. But to his utter surprise, what did he see? Yes, he saw that no, most of the alpha particles were actually going zoop. They just went inside and they passed through. They passed through it, right? They came out of the other side, which means that most of the atom is empty. It has vacant space, righto? Yes, everybody? Awesome. He also found out that, Achha, by the way, in Rutherford, what metal did he take? He took a gold foil. Why did he take a gold foil? He could have taken anything. He could have taken a copper plate. He could have taken an iron plate. But no, he chose gold foil. That is because, my dear student, gold is so malleable that he could beat it, he could hammer it down, and he could get the thickness of the gold foil could only be just 1000 atoms. Yes, so gold is one of the most malleable metal, and that is why that was the chosen element, right? Now from here, what happened? He saw that, see, these were just directly passing straight through the atom. That means that atom is empty. Right? This is what we understood. From here. Now from the next one, we saw that some of the alpha particles, what happened was they went and then they saw something and they deviated from their road, right? They were coming like this, like I see the camera and I imagine I don't like the camera, I'll deviate from it, right? Yes, this is what happened. This kept happening. So he understood that here there are probably some kind of force which these alpha particles are not liking. They are getting repelled by it. They are running away from it. Yes, dun, 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 dun. They are running away from it. So that means that there is some kind of positive force, and we know that alpha particles are positive. So repulsion, positive repulsion. It deflected by small angles. Understood. Great. Yes, very simple, very easy. We understood this. Okay, making sense. Now, from here what happened? Then he saw that there were very few alpha particles which came like this head on and just went back like this, right? They came, they hit it and they came back directly in the same road. And that means that the nucleus of the atom is actually at the center and it takes very small space. So if you consider the size of the atom and the size of the nucleus, yes, there is a difference. There is a huge difference. Now you might be thinking that, but ma'am, Atom is only so small, we can't see it through our eyes. Absolutely. Absolutely understood. Now imagine this, okay? My house is definitely a lot smaller than Ambani's house, right? You could fit probably 20 of my kind of house in Ambani's house, right? Ambani ji is really rich, right everybody? Yes, right? Absolutely. But someone who is sitting in, let's say, another solar system, they will probably be laughing like, they are thinking his house is bigger, her house is smaller. The earth is only very small, earth is only tiny. Understand the comparison? Yeah? Do you understand the comparison? Yes. Like if you look at earth from a different solar system, you will probably not even be able to see the earth. So same way, atoms are not visible to us, but inside atom, the nucleus take a very small region and most of the atom is empty. Got it clear everybody? Can I have some easy peasy biryani is tasty? So Rutherford is done. Now, what happened was, now Rutherford, he noted down what are the things that he observed. Exactly all the things that I told you. Yes, whatever I told you, these are all the things that he noted it down. Okay. Now, what are the limitations? Of course, nothing comes in the world without any disadvantage. So, there are disadvantages. What are the disadvantages? He saw that it does not obey another scientist, yes. He does not obey Maxwell's theory of electrodynamics. Maxwell, see, Rutherford, what he did was, there was just one simple thing that he said which messed up with his whole model. Everything else was fine. He said that an atom consists of the tiny positively charged nucleus at its center. Sure, this was absolutely correct, right? Rutherford also said that nucleus contained positively charged particles, almost entire mass of an atom, and all the positive charges concentrated in the nucleus. Absolutely correct. This also seems correct. Now what he said, remember, electron revolve around the nucleus in circular paths called as orbits, and this model resembles the solar system, thus called as planetary model. Yes, this is that point that messed up a little bit. How? See, according to Maxwell said that if something is revolving around, understand, if something is revolving around like this, okay, this is an electron. So what does the electron do? At every point, it changes its direction. Remember tangent, right? Yes, every point it is what? It is changing its direction. That means it is, yes, that means what is happening is, that means here, it is accelerated motion, and if something is in accelerated motion, that means that it is going to lose energy. So once it starts losing energy, what will happen? At certain point of time, there is a possibility that maybe the electron will just fall into the nucleus and everything gone, everything is just over. This particular point, my dear student, okay, this particular point actually questioned the whole existence of the atom. What did it do? Question the whole existence of the atom. If this point was so correct, then atoms would not even exist. That was first limitation. Yes, all right. This messed up completely Rutherford's model, but everything else was on point. It could explain the stability. It could actually tell the the possibility of where you might find electron, where you might find proton. Everything was there. Yes, but then this messed it up. Then came Planck's quantum theory. This is where your actual JEE portion starts. Okay, this is where we have to actually start the JEE portion. But the story is important. The story is very important now. So according to Planck's quantum theory, yes, so these were all very age-old traditions or classical, you can say. Now comes the quantum, the modern, yes, because science has advanced now, technology has advanced, and now we come to Planck's quantum theory. What did Planck say? Planck said that different atoms and molecules, they can emit or they can absorb energy only in discrete quantities. Okay? Yes, and the smallest amount of energy that can be emitted means produced. Yes, what is emit? Emit means produce. Yes, emit means produce, and absorb means taking it in. Yes, absorb means taking it in. So the smallest amount of energy that can be emitted, that can be produced, or that can be absorbed in the form of electromagnetic radiation, from now on we will call it as EMR. Yes, electromagnetic radiation is called as quantum. Yes, quantum, singular quantum, plural quanta. Now this quantum, what does it possess? It possesses energy, which is photon. Yes. So the energy of the radiation absorbed or emitted is directly proportional to the frequency of the radiation. Now what is frequency, my dear student? What is frequency? Chalo, let's have an analogy. How many of you like Oreo biscuit? How many of you like Oreo biscuit? Can I have it in the chat box, everyone? Yes. Also, I see very less interaction, guys. What's going on, yeah? Are you all very sleepy after the lunch? Yes? Okay. So can I say that, can I just assume that most of you like Oreo biscuit? Yeah? Okay. Now, how many of you like Marie biscuit? You all will be like, no ma'am, with Marie biscuit, we at least need some tea, ma'am. We need something, ma'am. No Marie biscuit. Yeah. Right? No one likes it. Okay. Now, if I give you a timer, if I give you a time, I say that, hey, I give you, let's say 1 minute. Okay. I give you 1 minute. All right. And in 1 minute, I want you all to eat, let's say that I give you 2 minutes and I want you all to finish the Oreo biscuit as well as the Marie biscuit. Now, after 1 minute, when I come back, what do I see? I see that you have gobbled up all the Oreo biscuit. Your mouth is like, oh, you're chewing somehow and you're gulping it down. Yes? Yeah. But when it comes to Marie biscuit, you have max to max eaten 2 Marie biscuit and you're like, ma'am, I just can't, ma'am. This is it. That's it. I think we're done, ma'am. I think we're done, right? Yeah. So what does it mean? What is now, if I ask you, what was the frequency of Oreo biscuit that you have had? You have obviously more. What was the frequency of Marie biscuit that you have had? Less. Yeah. So what is frequency? Frequency is number of biscuit passing through your mouth, my dear student. Number of biscuit passing through your mouth. Yeah. So using the same analogy here now, what is frequency? Frequency is number of waves passing through a point. Yeah. What is frequency? Number of waves passing through a point. That is what is frequency, my dear student. Yeah. Okay. All right. So is this clear, everybody? Easy peasy, biscuit is tasty. Oreo biscuit, everybody loves Oreo biscuit. So from this example, you can remember what is frequency? Number of biscuits passing through your mouth. Which one was more? Obviously, Oreo biscuit, more Oreo biscuits pass through your mouth. You ate them, you gobbled up, right? Whereas Marie biscuit, you're like, ew. No, ma'am. No, ma'am. You did that? Yeah? So that's it. That's it, done. So frequency we have understood. Okay, so that means once again, what did I teach? I just told you that the energy of the radiation absorbed, whatever energy you have absorbed or you have radiated, yes, is directly proportional to, it is directly proportional to the frequency of the radiation. Understood? Yes. Awesome. Absolutely right, Tamil. I agree. Veg biryani is not tasty. In fact, veg biryani, I feel like it's a scam. Yeah. We should not even call it. Yeah. We shouldn't even call it biryani. That should be called as salted rice. What do you think? I think that's right. Yeah. It should be called as salted and colored rice. Yeah. Yeah, actually. All right. Moving on. Now, now, do you think that only this much theory is enough? Do you think that only this much theory is enough to understand what Planck's quantum theory told us? No. Now we go to derivations and the tougher part is coming up. Let's rev it up. Let's rev the engine. Oh, hey, Rex 9, happy birthday. Happy birthday. No problem, Bicha. No problem. You are allowed to celebrate your day. It's fine. Anyway, now let's focus. Yeah. So, energy of photon. What is the energy of photon? It is E is directly proportional to mu. Yeah. What is it? E is directly proportional to mu. Now this sign that you see, we have to remove it. We have to remove it, and what do we have to do? We have to put an equal to sign. If we put equal to sign, then that means that we will also need a constant. What is the constant? The constant is Planck's constant. Right off? Clinical clear? Yes? Clinical clear, guys? We understand this. Now, don't you think that E is equal to h mu? It can also be written as hc by lambda. Why? Because we know that nu is equal to c by lambda, where c is the speed of light. Lambda is the wavelength. Acha, what is wavelength? What is wavelength? Everybody is clear with wavelength? Chalo. Let's say that if I make a graph like this, yeah? If I make a graph like this, now what will I do? I will do this. These are my waves. These are my waves. Now from one distance, from here to here, the distance between two crest or two trough, that's called as wavelength. This is called as wavelength, okay? Basically, what was the difference? You have taken one Oreo biscuit, put it in your mouth, now you are chewing. The next time when you are reaching for the second biscuit, one biscuit, second biscuit, the time difference between the first biscuit and the second biscuit, that's your wavelength. That's your wavelength. Understood? Same thing here. Or it can be from here to here. What is the distance here? That is also your wavelength. Easy peasy. Biryani is tasty. Right? Right, guys? Yes. Okay. So, the distance between two troughs and two crests is called as wavelength. Chalo. Done? Over? Great. Moving on from here. Now, this from the Planck's quantum theory, we come to Bohr's atomic model. Okay? Yes, Bohr, Niels Bohr. Who gave the theory? Obviously not Navamita Bhattacharya, right? It was given by Niels Bohr. But see, same initials. NB. Niels Bohr is also NB. I am also NB. Isn't it? Yes, NB. You have to remember, okay? Niels Bohr. Yeah. Yes. So, Niels Bohr, he was the first one who explained quantitatively, my dear students, not qualitatively. What did I say? Quantitatively, he explained the general features of the structure of hydrogen atom and its spectrum. Basically, what he did was, he mostly worked on single electron system. Okay, we spoke about single electron system. Chalo, we will talk about that in some time, but anyway. Now Bohr said that he also used Planck's concept of quantization, yes, quantization of energy. Oh, just a sec. Tamil, bacha, we are coming to it. I told you, no, we will also have to focus on our concept clearation, bacha. If we don't remember the concept, then how will we do a problem? I can't do that, no? Acha, this was your reminder also to drink water. And by the way, half an hour or so, keep reminding me that I must drink water. Hydration is very important. And thank you so much, Riddhi Reads. I hope that you will also share it with your friends. Yeah, thank you so much, bacha, that you are liking it. Acha, anyway, okay. Hey, don't jump before me, Krishna. Shh. Shanti. Krishna, Shanti. We will go there. Don't worry. Everything will be covered. So, quantization of energy, right? Now, the electrons in the atom. Now, Bohr, very smart, huh? What did he say? He said that the electrons in the atom can move around the nucleus in a circular path of fixed radius and energy. Fixed radius and energy. Take a look at it. Circular path of fixed radius and energy. And these paths, what are they called? Orbits. Yeah, common sense. Come on. Orbits. Stationary states or allowed energy states. Okay? These orbits are arranged concentrically around the nucleus, of course. This also we know. Right? Of course, orbits. Now, what did Bohr say? See, Bohr gave some postulates. And the best thing that he did was, he said that, yes, the electrons are moving in their own path. They are fine. They're absolutely fine. But the moment they jump from one shell to another, that's when they either release energy or they absorb energy. Yes, that's it. When they are moving around, they're actually not doing anything. They're fine. They're like, yeah, we are stable, fine, we're moving around, it's all right. But the moment they have to jump, that's when they either emit or they absorb. Is this clear? Now, let's come here to postulates of what? Postulates of Bohr's theory. Here we go. He said that electrons revolve around the nucleus due to the centripetal force. Obviously, centripetal force we do understand, right? If I take a rope like this and if I keep rotating like this, why will it rotate? Because there is centripetal force. Because of the centripetal force, it is in the circular motion, nothing else, just centripetal force. So that means I can also say that this centripetal force, okay, this centripetal force which is provided, who is providing the centripetal force? If I take a rope and there is a stone at the end, I can rotate it. Why? Because I am providing the centripetal force, right? I am the one who is providing the centripetal force. But here, who is going to provide? Who is providing the centripetal force? The answer is yes, absolutely yes. There is nucleus. That means that if there is electron, there is electrostatic force of attraction. Right, my dear student? Yes. Electrostatic force of attraction is here. Yes. 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 Clear the difference between centripetal and centrifugal. Okay. Who doesn't know the difference between centripetal and centrifugal? I'll have to, of course, deviate a little bit, but sure. Yes, bacha, you'll be getting the short notes. Don't worry about it. Yes, yes, yes. EMCT will be done. Yeah, you guys don't worry about EMCT. Why are you so worried about EMCT? We will take care of it. You can see, right, the amount of focus that we are building it up for your JEE. The same amount of focus will be given to EMCT. And guys, whatever we are teaching you right now is actually important for EMCT also. Just because it's not written on the thumbnail that it is EMCT doesn't mean that it is not relevant to EMCT. You can always watch it. Yeah, very good, Siddharth. Okay. Yes, acha. Centripetal is what is provided from the inside. Yes, centripetal is what is provided from the inside. Now, to keep the, see, if I rotate like this, okay, if I keep rotating like this at my same position, I will need some force to actually rotate at only this position. Otherwise, I'll go somewhere else, right? While rotating, I might go somewhere else also, isn't it? Because you remember, direction changes. There is tangential force also acting on it. Tangential force is also acting on it. So the direction might change. Now, to keep the electron or keep anything that is rotating because of centripetal force, to keep it in this circular motion, there is a balance force from outside. There is a balance force from outside which is actually a pseudo force. That pseudo force, that outside wala force, that's called as your centrifugal force. Is this clear, guys? Is this clear now? Yes? Is this clear? Got it? Yes? And like we said, Maxwell, what did he say? That if it is accelerating, it will come inside, it will fall inside. We don't want that. We don't want that. Somebody has to pull it and keep it right at its position. And who does that? Centrifugal force. Yes? So centrifugal, centripetal, both of them balance each other, and that's why it is rotating like this. Got it? Cool? Okay, moving on. Now, what did I say? Here, because of electrostatic force, centripetal force is there. So that means that my centripetal force is equal to my electrostatic force of attraction. Am I right? Am I right? Yes? Understanding or not, guys? Yes? What is my centripetal force? mv square by r. Do we all know this formula? mv square by r, which is equal to kZe square by r. What is this? This is my electrostatic force. This is my electrostatic force. Yes, okay, all right. Now moving on from here, see, energy is emitted or absorbed when an electron jumps from one orbit to another. I just told you this, right? I have just told you that energy is emitted or absorbed. Whenever energy is produced or it is absorbed, it is only done when? When is it done? It is only done when they jump from one shell to another, okay? So the amount of energy that is emitted or absorbed, very conveniently, we can also say that is just the difference of energies. We can say that. Yes, we can say that. Very conveniently, we can say that we will say that it's just the difference between the energies of the orbits. That's it. That's it. So that means, what can I write? I can write that delta E, the difference of energies is E2 minus E1, which is basically H mu is equal to Hc by lambda. Am I right? Am I right? Yes? Yes, absolutely right. Okay. Now, according to Bohr's postulate, see, once again, everybody, what did we say? We just said that centripetal forces is equal to Coulombic force. So, same formula from here, I'm taking this formula and I'm putting it here, okay? Now, one R will cancel. So, what do we get? We will have only one R. Yes, yes, we will have only 1 r. 1 r will be equal to what? KZE square divided by mv square, where m is the mass of electron, E is the charge of electron, Z is the atomic number, V is the velocity of electron, and R is the radius of the orbit in which electron is revolving. Are we all clear with these many terms? Yes, are we all clear with these many terms? Yes? Very good. Chalo. Moving on from here, now what do we understand is that what Bohr did, see, according to one of the Bohr's postulates, again you have read it in your NCERT, right? Yes. So in your NCERT it's written, see, MVR. What is MVR? What is MVR? What is MVR, guys? Hey, no one is telling. What is MVR? Momentum, angular momentum. So MVR is basically n into h times n times of h by 2 pi. Yes, this is what he said. And what is n? N is basically 1, 2, 3. Yes, 1, 2, 3. Okay, angular momentum. Yes. Now, from here, what he did, he just rearranged it. Just rearrange this. This is your formula. This, once you rearrange, what do you get? You get V is equal to NH divided by 2 pi mr. Yes. Now, what we can do is, see, from here we got equation 1. From here we got equation 1, that is R value we have found, right? We found the R value is equal to KZE square divided by MV square. If we put that in the place of R, if we put this, or what we will do is KZE square divided by MV square. So if we substitute it, what do we get? We will get R is equal to N square H square divided by 4 pi square M KZE square. Yes. Now in this case, everything is constant, my dear student. Everything is constant. Yes. All of these are constant. See, M is constant, K is constant. Yes. Yes. E is constant. E is constant. Yes. H is also constant. Only thing that are not constant, things that are variable is N square, N and Z. These two are variable. So once you put all of these constant in this equation, what do you get? You get R is equal to 52.9 N square by Z picometer. This you will have to remember. This you will have to remember. Put a star mark. I will put a star mark. This you will have to remember. Okay, 52.9 into N square by Z square. Okay, N square by Z square. 52.9 into N square by Z. N square by Z. Did I say Z square? No. N square by Z. Yes. Alright, do we understand this? Great. Now, once again, same thing we will take. MVR is equal to NH 2 pi. Okay. And now we also know that what is R? R is equal to, we know that, see, N square into H square divided by 4 pi square MKZE square, right? Yes, we already know this. This is our second formula that we got. Second formula that we got. Yes, 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 yes or not? No one is telling anything. Tough to remember. Rex Knight, write it with me. Write it with me while I am telling. You will get it. Yes, Dushyant, you will get the class note. Don't worry. Chemical bonding is coming up at the end. You have to stick to it. You have to stick to the session. I told you that. You have to stick to the session. If you come and go, then I'm so sorry. You will not be able to get all the marks, bacha. Yes, you will have to stick to it so that you understand everything. Now for here, okay, putting value of R in this equation. We know that R value is this. This is our R value. This value, what we will do is, we will put it here, okay. Then what we will get? What will we get? We will get V is equal to 2 pi k Z square divided by NH. Yes, you can solve this. You can solve this. Okay. Krishna, I will take care of organic also. You don't worry about it. Are you liking the session now? Are you liking the session now? Is it interesting? Is it fun? Is it exciting? Then this is exactly the way how all your sessions will be. Don't worry about it. Don't worry about it, okay. I'm here. I'll support you as much as I can. Okay? Yeah. But I want your support. I need you all to call up your friends and bring them here, because I want you all to get benefited from these kind of videos. I mean, I'm not just like passing time. Yeah? Chalo, moving on. Okay. Now, what we do is, so from here we have understood the velocity of electron. How to find out velocity of electron? Like this. This is our velocity formula. Okay? This is our velocity formula. So we understand this also. Now moving on, we have to find the energy of electron in Bohr's orbit. What are we doing? Energy of orbital. Arey bhai, see, if I come what did you do? The first time when I came to this channel, what did you ask me? You asked me, ma'am, your name, ma'am, your qualification, ma'am, what did you do, ma'am, where were you teaching, ma'am, what have you been doing, ma'am, where are you from, ma'am, where do you stay? There were so many questions you asked me, right? Because you wanted to know about me. So obviously, when we talk about electron, we want to know all the terms and conditions that are applied to the electron. So we have understood the velocity, we have understood the radius. Now let's understand the energy of electron in Bohr's orbit. What is the energy? Total energy is obviously equal to kinetic energy plus potential energy, right? Yes. Now kinetic energy, let's derive it. So kinetic energy, we all know, we have learnt it in physics, half mv square. That's it. Kinetic energy is equal to half mv square. We know this. Yes, we have learnt it. Shreyas sir, right? Just recently only he took the session. I hope you watched it. Yes. If you have, then I'm pretty sure that you know this. Yes, half mv square. Now from Bohr's postulate, we also know that mv square by r is equal to kz square. Do you see that this formula is getting repeated? This formula is getting repeated from our previous slides. Yes, yes. So that means what do we get? What do we get? Comparing these two, we will get that kz square divided by 2r. A little change. Instead of r square, this time it is 2r. R square, nah, it is 2r. Yes, okay. So this is our K. Now, now what is our potential energy? Our potential energy is same as K, okay, same as K, but two differences. There is a minus sign here and there is no 2r, there is r. Huh? Okay, there is r. No, it's not half an hour. Funny shots. Remind me at 3. Remind me at 3. So now what is our total energy? What do we have to do? Add, yeah. Potential energy plus kinetic energy, right? Yeah. So, kz square divided by 2r minus, why minus? Because this is negative. This is negative. So, minus kz square by r. What will we get? What will we get? Easy peasy, biryani is tasty. We will get minus kz square divided by 2r. Yes? You know mathematics, no? Take LCM, do this, do that, all of that, however, whatever you do, and you will get this. This is our total energy. This is our total energy. Now, trick. Your cheat sheet. What is your cheat sheet? How will you remember? This is your cheat sheet, okay? This is your cheat sheet. So, in short, how will we remember? We will remember that it is K plus P is equal to minus K is equal to half P, okay? So, potential energy is basically minus 2 of kinetic energy, yes, minus 2 times kinetic energy. And total energy is always equal to negative of kinetic energy. This is your cheat sheet. Remember it. Write it down with star marks, or anyway you are going to get the PDF. You can watch it from there also. Okay. Alright. Wrote that. Very good. So this is your cheat sheet. You have to easily remember it. Okay. Easily in the exam hall. How will you remember it? That's it. Chalo. Moving on from here now. Yes. Moving on from here. Funny shots. Hey. No Oscar and all, we're talking about chemistry. Chemistry is what we're talking about. Yeah. So now what we are going to do is, see, total energy is equal to, we just did that, no? Just solved it, isn't it? This formula, let's take it here, okay? This formula, we'll take it here. Now we already know the R value. Do we know the R value? We know the R value. Yes. After knowing the R value, if we put it here, then total energy value will be 2 pi square z square e to the power 4 k square m divided by n square h square. So, bacha, if you are asking me how will we remember all of these? How will we remember all of these? The clue is to remember the first two and then easily derive. Or what you can do is have a formula sheet, write down all the formula. Yes, write down all the formula and stick it right in front of your eyes so that every single day when you keep seeing it, you will remember it. Okay, this is your easiest way to take it down. Now again, once again, we know the value of K, we know the value of E, we know the value of M, we know the value of H in the above equation. So once we put it, what we will get? We will get E is equal to minus 2.18 into 10 to the power minus 18 into Z square N square. What is this? 2.18 into 10 to the power 18. In your book also it is written Rydberg's constant. Yes. Is it written or not? Is it written or not, guys? Yes. Yes. Isn't this Rydberg's constant? Yes or no? Hello? Wake up. Okay, I'll stay silent if I don't see chats. Guys, wake up, wake up. What you're doing? Yes, finally. Yes, yes. I need interaction, otherwise I will also get bored and I'll step out of the class. Rydberg is different. No, Rex Knight. See, in your book also it is there. But there is another this thing also 109. 109 that number starts with. Yeah, that is also there. That is also there. But in your book this is also written. Chalo, theek hai, let's not confuse ourselves. Let's not confuse ourselves. Let's remove this. Theek hai? In NCERT it's written like this, but chalo, theek hai, let's not confuse. Anyway, so once we put all of these, we will find that E is equal to minus 2.18 into 10 to the power minus 18 z square by n square. Why again? Because z and n are the variable ones. Yes, z and n are variable ones. Great. Yes, now what we are going to do is, acha, so this was in joule per atom. Now if we change it to electron volt per atom, then this is our formula. Okay, this is our formula. Moving on. All these while, we have understood a lot. And we understood that Bohr's model was crazy, revolutionary. Yes, changed the face of it. We could understand how the atom would look like. We would understand how the electrons are going to stay. Everything is fine. But limitations. There is limitations here as well. What are the limitations? This time we could find out that it could not explain the line spectra of atom containing more than one electron. Yes? No. I told you. What did he give? He gave one electron system. He specifically told us about one electron system, but this time more than one electron system failed miserably. Then he could not explain the presence of multispectral lines. It couldn't do. Yeah. Bohr could not explain the de Broglie's concept of dual nature of matter as well. Acha. Again, a lot of you are going to say, ma'am, it's not de Broglie, ma'am, it's de Broglie. No. Again, as Indians, we like to spoil things a little bit, so we call it de Broglie, but it's actually not pronounced as de Broglie, it's de Broglie, okay? It is de Broglie, correcto? Okay. So, Bohr could not explain the de Broglie's concept of dual nature of matter. He could not explain the splitting of spectral lines. Yes, splitting of spectral lines in the presence of electric field, which we know is Stark effect, and the magnetic field, which is known as Zeeman effect. Yes. Yes. So, he could not explain Heisenberg's uncertainty principle, which we will be reading now. Okay. Alright, these were the limitations. Now, moving on. Yes, hydrogen spectrum. So, line spectra of hydrogen atom, who observed it? Balmer. Balmer did it in 1885. Do you have to remember the dates? Not at all. It's not history. We are learning chemistry. Yes, but just for your story purpose, I have told you. Yes, just for that story purpose, I have told you. Now, if you take hydrogen gas at low pressure in a discharge tube, remember the discharge tube? Yes, how all those cathode ray experiment, anode ray experiment, perforated cathode, we have done it in the first part of the chapter. Remember that? Discharge tube? So, something like that only discharge tube we have taken. Now, the light emitted on passing electric discharge is examined with a spectroscope. Yes, and the spectrum that you have obtained is here emission spectrum of hydrogen. So, Balmer did it first. Yes, Balmer did it first. This is basically what happened. He took a discharge tube which contained hydrogen gas. Yes, there was a lens, there was a thin slit, there was another lens, then there was a prism. When he did that, he found out the emission spectrum. Okay, he found out the emission spectrum. Yes. Now what happened was, yes, see the same thing, minus 2.18, just some time back we found out this minus 2.18 into 10 to the power minus 18, same thing, we will put it here. Okay, we will use it here. Once we use it here, now we find the Rydberg's constant. What is it? 109,677. Okay, 109,677 per centimeter. Yes, Rex Knight, Lyman, Balmer, Paschen, bracket, Fund. Yes, these are the series that we come. Now, what Rydberg did was, see, understand, Balmer did it first. Yes, Balmer did it first. No doubt about it. But Balmer's was very specific. Rydberg wanted to generalize it, and then when he did it, this becomes our formula. What is this? This is our formula. 1 by lambda, which is equal to mu, is equal to RH into Z square, 1 by N1 square minus 1 by N2 square. What is N1 and N2? What is N1 and N2? Obviously, we know, yeah. What is N1 and N2? See, N1 and N2 are basically the numbers of the orbits. Yeah. Okay. So, from here we can see there is Lyman series, there is Balmer series, there is Paschen, and there is bracket and fund, okay? So if it is N2 to N1, yes, for 1, N2 to N1, if it is 1, it is Lyman series, okay? Like from here, see, N2 to N1, it is Lyman series. Yes, N2 to N1, if it is 2, then it is going to be Balmer series. If N2 to N1 is equal to 3, then it is Paschen series. N2 to N1 is equal to 4, it is bracket series, and same like fund series. Okay, we get it. Yes, bacha, it's all written Rex night. I hope that you can see. It's all written here. See, this is ultraviolet, this is visible, this is infrared. It's all written, and you know it. It's very common. Yes, it's very common. Chalo. Once again, here it is also written. You can check it out. See, N1, and if N2 is 2, 3, 4 for Lyman, then it is ultraviolet. For Balmer, it is visible. For Paschen bracket fund, it's all infrared. Okay. All right. It's all infrared. Okay. All right. Moving on from here. Now comes our very important part, de Broglie's hypothesis. Okay. De Broglie said that according to de Broglie, basically what happened is the wavelength of a moving particle of mass m with a velocity v is given by lambda is equal to h by mv, which can also be written as h by p. What is p? P is momentum. P is momentum, v is velocity, mass of the particle. Very easy, very simple, very easy, everyone. Yes, makes sense or nonsense? Makes sense or nonsense? Yes, guys, what's going on? Understanding or not? Again, I don't see any chat. Hey, you all are sleeping or not? What? Huh? Don't sleep, Baba. Don't sleep. I want you all to concentrate here so that in the evening you can do your own this thing. Okay. Great. Awesome. So that means if we want a relationship between wavelength and kinetic energy, yes, if we want a relationship between wavelength and kinetic energy as per whatever we know, let's put it here. Let's put it on the paper. Yes. So lambda is equal to h by mv. We know it. What is kinetic energy? Half mv square. So we have two equations. Yes. Now what we'll do is we will square the equation 1. Yes. What we will do? We will square the equation 1. So lambda square is equal to h square by m square mv square. Rearrange it a little bit. What do you get? You get mv square is equal to, see, mv square is equal to h square by lambda square by m. Okay. Now that means that in the place of mv square, we can put this value. When we do that, what do we get? Lambda square is equal to h square divided by 2mke. Because there is square, we have to remove the square. Once we remove the square, what will we get? We will get a square root. So lambda is equal to h divided by 2mke. Yes, 2mke, right? Now what happens? We also want to understand Heisenberg's uncertainty that Bohr could not explain. Heisenberg said that, very simple, very easy, guys, yes, Heisenberg said that for an electron, okay, you cannot find the exact position and the momentum of a fast moving particle simultaneously. As in, right at the same point, you can't find the position and you can't find the you cannot find the momentum. That means that it becomes delta x dot delta p is greater than or equal to h by 4 pi. What is delta x? Delta x is the uncertainty in position. Delta p is the uncertainty in the velocity. Yes, or delta v. We can also write it like this, and then we can find out the delta x is uncertainty is position and delta v is the uncertainty in the velocity. Yes, velocity, absolutely. And as per Heisenberg, every time if this is true, then this will be false. If this is true, then this will be false. Okay, you cannot find both of them correctly at the same time. Is this understood? All clear, guys? Yes. Now we come to next part of the story. Yes, that is our photoelectric effect. Now, photoelectric effect is actually a very old experiment which Einstein took it and he just modernized it a little bit. What did he do? In the photoelectron effect, we found out that if you take a metal sheet, am I running too fast, guys? Am I running too fast, or is it fine? We have to understand that time is what is less with us and we have to run a little bit, yeah? I mean, you understand that although we will be doing in detailed everything, but we still have to do it a little fast, okay? Fine? Okay, cool. Thank you so much. Acha. So what is photoelectron effect? Very easy. You take a metal plate, incident light falls on it. When light falls on it, there are some particles that just come out of it. They want to jump. Okay, makes sense, right? Absolutely makes sense. There's nothing nonsense with it. Yes? Yeah. So when radiations with certain minimum frequency, right, minimum frequency, they strike the surface of a metal, the electrons are ejected from the surface of the metal. We understand this. We understand this. Great. Acha. Now, according to Einstein said that if the frequency of the incident light is more than the threshold frequency, the excess energy is imparted to electron as kinetic energy. Let's understand it with a different example. Acha. A lot of us, what do? We drink coffee to wake us up in the morning, yeah? What do? We drink coffee to wake us up in the morning. Now, obviously, there is, let's say, 1 teaspoon of coffee that is going to wake me up. 1 teaspoonful of coffee, if I make it, I'm going to wake up. That's my threshold. My threshold is that 1 teaspoon of coffee, that's it I need, and that's going to wake me up. I understand that. Now, what happened is, one fine day, let's say yesterday, yeah? So yesterday, my husband is also a drummer actually. So I had been to watch his show, right? Yes. So I came home late. We came home late after the show, and I slept very late. So obviously today what happened? I had to take 1.5 or 2 spoons of coffee to wake me up a little more. I needed it. Now, do you know what happened here? My body is accustomed to me having. Are you married? You didn't know? I am married. It's been 2 to 3 years now. 3 years running. Yeah. Also I'm old. If you think that I'm very young, no, I'm quite old. It's just I don't look like, because yeah, height, didn't eat so much protein when I was younger, I guess. Anyway, coming back to the point. So what I was telling you was, now my body is accustomed to me having 1 spoon of coffee. But what happened? I had 2 spoons. Now I'm hyperactivated. Now I want to do more things. So this is what? Kinetic energy. I want to move, I want to dance, I want to do everything, right? Yes. So this is my kinetic energy. Yes. This is the coffee, the rest of the coffee that is pushing me to do certain bit of activities that normally I probably would not have. If I only had 1 cup of coffee, 1 teaspoon of coffee, I'd be like, theek hai, let me move. My work should just, my work should just go on. This is how I'm supposed to run my errands. This is how I'm supposed to run my day. But today, all I want to do is, maybe like hyperactive. I want to probably like go down and come up the stairs like 10 times. That's something that I want to do. Yeah, exactly. And that's exactly what is happening. So there is a threshold energy. There is a threshold frequency which you give. Yes, the electrons will go. But if you give more than the threshold frequency, then what will do? What will it do? What it will do is, it will take the energy, it will eject, and then it will move. Okay? It will take the energy, it will get ejected, and then it will start moving. So, kinetic energy of the ejected electron, half mv square, basically we can write it as hv minus hv naught. Yes, or hv is equal to hv naught plus half mv square. This is your your equation. Okay, this is your equation. Cool. All right, everybody. Yes. Chalo, moving on then. From photoelectric effect, what do we have to move? Another important part is Schrodinger's equation. Okay, a lot of people will tell you a lot of things. It's a Schrodinger, this danger, that danger, but it's Schrodinger. So Schrodinger derived an equation which described wave motion of an electron. Yes. What do we know? We know that wave motion of an electron. What did he say? He said that this is the equation: d square psi divided by dx square plus d square psi divided by dy square plus d square y psi by dz square plus 8 pi square m divided by a square e minus v psi is equal to 0. Yeah. What is psi? What is psi? Psi is wave function. Psi is wave function. Psi. This is called as psi. Psi. Okay. Alright. So, psi. See, wave function of the electron. H is your Planck's constant. V is your potential energy of the electron. Total energy of the electron. M is equal to mass of the electron, and X, Y, Z are basically the Cartesian coordinates of the electron. If you plot an electron, then the electron will have to fall into X, Y or z, isn't it? Somewhere it has to lie. So that's your Cartesian coordinates, and that's how you do. Wave function mane electrons wave motion mein hai. Yes, they are in the wave motion. So you will also need a wave function, okay? You will also need a wave function, isn't it? Now, what are the significance of psi? Now comes your answer, Rex Knight. Take a look at it, okay? Now, no, not phi, psi, 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 psi. Rex Knight, chill. Coming to it. So, what is the significance of psi? Yes, what is the significance? What is wave function? Oi, you guys, are you in 12th? Are you appearing for JEE? Or are you in 11th? If you are in 11th, no problem. There is still a lot of time. You will be able to understand everything. But if you are in 12th, my dear student, you know that we have to run. Yeah? How come you are asking me what is wave function? Huh? Now, anyway, understand this. This is psi. Psi is your wave function. Yeah? Okay. Once again, everybody, psi. This is psi. Yes? This trident thing like Shiv's Trishul. This is PSI. What is this? Wave function. Okay, what is wave function? What is the significance? What is the importance? Here we go. Let's read it. Let's read it. So the wave function, what it can be regarded as the amplitude function expressed in terms of coordinates. What is amplitude? What is amplitude? Chalo. Acha. Let me give you the example of amplitude as basically. Okay. Let's talk about sound a little bit from physics. Let's understand amplitude from physics, okay? Yes, bacha, I will be covering whole topics in this topics. Yes, absolutely. Don't worry. So imagine there is a particle, okay? There is a particle that is near my mouth. This particle is chilling, okay? Nicely it is chilling. But what happened is I just said, hey. Once I say, hey, the particle starts moving. Yes? But the particle was at rest here. From here, it moved forward, came backward, forward and backward. So, from its rest position, the maximum it went forward or it came backward, that is your amplitude. Yes, that is your amplitude, basically the height of the wave. Absolutely right, Likhit. Yes. Basically the maximum height of the wave, that, my dear student, is your amplitude. So coming back to it, what is the wave function? It is the amplitude function. Yes, it will be the amplitude function expressed in terms of coordinates. Yeah. Now the wave function, it may be positive or it can be negative values depending upon the value of coordinates. If it is plus x or if it is minus x, if it is plus y or minus y, if it is plus z or minus z, it can be, the wave function may have positive or negative values. The main aim of Schrodinger equation is to give solution for probability approach, okay, for the probability approach, what Heisenberg did. Yes, what did Heisenberg say? Heisenberg said, forget everything, now this is all on probability. Everything is based on probability, right? So for the problem, for the probability problem, to find a solution for that, this is why he gave it. Okay? Yes? Now, when the equation is solved, it is observed that for some regions of space, the value of psi is negative. What do we see? That some regions psi is negative. But the probability must always be positive. Yes? The probability must always be positive and it cannot be negative. Yes? The probability has to be positive, it cannot be negative, and that's why we don't want to use psi, rather it is proper to use psi square. Okay? It's proper to use psi square in favor of psi. Do we understand? Probability has to be positive, but the psi value can be negative as well. So what is the significance of psi square now? Now psi square is the probability factor. Psi square is the probability factor. What does it describe? It describes the probability of finding an electron within a small space. Yes? Finding an electron within a small space. And the space in which there is maximum probability of finding an electron is your orbit. Yes? Is your orbit. Thank you so much for reminding me to have water. Let's just take a little break for some seconds. Yes. Alrighty. Moving on from here. Now we have to understand the orbits and the quantum number. Yes. Now we have to find the orbits and the quantum number. According to Heisenberg, we cannot find electron's position. Hey, Gautam, Heisenberg said that the electron position and the momentum cannot be found simultaneously. You can't do two things together. You can do one thing. You can't do two things. Like, remember when I was younger, there used to be Shaktiman, and Shaktiman said that, Thero, if you are going in a car and if you are reading a book, not allowed. If you are eating and you are watching TV, not allowed. You can't do two things together. You can do one thing. That's what he said. Okay? Alright? Now, when we talk about the orbitals and the quantum theory, what do we talk about? What do we see? For S orbital, we know N. N is what? Principal quantum number. What is L? L is your azimuthal quantum number. And what is M? Magnetic. Right? N, L, M. Principal, azimuthal, magnetic. Arey PYQ aayenge. Wait. There will be PYQ. Don't worry. As we have told, whatever is promised, everything will be done. Chill Mari. Chalo. For p orbitals, we know that when n is equal to 2, 3 or you continue till 6, L is equal to 1 and M is equal to 0 or plus minus 1. Okay. For d orbital, n is equal to 3, 4 and 5, then L is equal to 2, M is equal to 0, plus minus 1, plus minus 2. Yeah. S you all know, it's there. F orbital, we can look at the shape, although it's a little complicated, but it's fine. We can look at this shape, right? So n is equal to 4, L is equal to 3. M is once again what? 0, plus minus 1, plus minus 2 and plus minus 3. Correct? We understand this? Do we all understand this, everybody? Great. Moving on from here, now we come to the node. Acha, what is node? What is node? Node we always know na bacha. What is node? Node is where two things meet. Where two things meet. So the region around the nucleus where probability of finding electron, yes, probability of the region around the nucleus where probability of finding electron is 0. Where you can find the electron is orbit, but where you cannot find where it is 0, that's called as your node. Basically, psi is equal to 0. Basically, psi is equal to 0. Probability of finding it is 0. Now, node is actually n minus 1. Node is actually n minus 1. How is it 1 minus 1? How is it n minus 1? Chalo. Now, node, there are two types of node. One is radial, across the radius, angular, angle. Angular. Now, so we can understand from the name only that it is angular, on the angles. Radial, across the radius. Yes. So, radial node is n minus L minus 1 and angular is L. So, n minus L minus 1 and L, then L will get cancelled. What will you get? You will get n minus 1. Formula solved. Easy peasy biryani is tasty. Yes, easy peasy biryani is tasty. We understand this. Great. Moving on. This is your radial node across the radius, as I told you. Across the radius. Yes. What are your nodal, what are your angular nodes? Across your angles, right? Across the angles. Acha, now these shapes are important. Okay, these shapes are important. This is for your 3D XY, 3D XZ, 3D Z square, 3D X square minus Y square, 3D YZ. Where do we need this? Where do you need this? I didn't forget. I said that spin number is also there, which you know it's there in your NCERT as well. I said that line. You did not hear me. Anyway, where do we need this? We also need this in coordinate chemistry, in coordinate compounds. So don't forget to check them out. Yes, clinical clear. Very good. Awesome. Now variation of radial wave function are basically if you plot the graphs, plot the graphs, what will you get? You will be getting, you plot the graph, you get a graph. From the graph, if you extrapolate it, if you just increase it, then you also find the shape of the nodes, which is what we just studied. So basically from this graph, when we understand the probability, where and all you can find the electrons, from this graph, when you extrapolate it, when you keep increasing it, that's when you also find the shape. So these graphs, once you have plotted it, what are the things that you can figure out? You can figure out where the electrons are present and what is the shape of the orbital. Is this clear, guys? Is this clear? And that brings us to the end of our first chapter, that is structure of atom. That's where we end the structure of atom. Now we're going to do some questions. So everybody ready? Everybody ready, guys? Everybody ready or not, guys? Come on, come on, come on. I want to know the answers. Yes? Chalo. Okay, let's do it. Will we get short notes? Haan na bacha, after the session ends, then I'll give you, okay? I think this class will go on till 5 o'clock. I think we will need 3 hours to complete it. Yeah, in 3 hours we should be able to complete it, hai na? In 3 hours we will be able to complete it. Chalo. So, the azimuthal quantum number for the valence electron in Ga plus ion is, atomic number of gallium is given. You have to find the azimuthal quantum number. Tell me. So, gallium's atomic number is given. That means that we will write it as Ga. So, 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, and then what will happen? What will happen? Or will it be ulta? It will be ulta, isn't it? It will be, no, 10, 10, 30 and then, yes, this is what it is. Yes, in the middle we can, I'll give you a break, don't worry. This is what it is. Now it is saying that it is gallium plus, that means we will write it as 1s2, 2s2, 2p6, 3s2, yes, 3p6, then we will write 3d10 and then 4s2, yes. Now what will be the azimuthal quantum number? 0. Very good. 0. How did we know this? How did we know this? Remember this? Do you remember this? See, 4s2, yes, 0, yes, very good, awesome, amazing. Chalo, moving on to the next question, guys, moving on to the next question. Tell me, work function of some metals is listed below. The number of metals which will show photoelectric effect when light of 300 nanometer wavelength falls on metal is. Batao, guys, how will you do it? Batao, how will we do it? Find the energy. Very good. You will find the energy. How will you find the energy? What is the formula? What is the formula of finding the energy, guys? Tell me. No, it's not 2. It's not 2. But tell me, how will you find the energy? Yes. Go ahead, let me know. Hc by, okay. E is equal to Hc by lambda. Yes. Yes. Okay. Let's do it. Hc by lambda. Now, what is our H? What is our H value, guys? You are only going to tell me. You tell me, I'll solve it. What is our H? What is our H value? 6 point. Ananti, yes, we can do that also. We can do that. 6.636 into 10 to the power minus 34. Yes. 636 into 10 to the power minus 34. Yes. Into, what will it be? Speed of light. So 3 into 10 to the power 8 meter per second. Yes. Now divided by, it is given as 300. Yes. 300 into 10 to the power minus 9 we will do because it's nanometer. Right. And what else we will have to add? What else we will have to add, guys? There has to be something else also. There has to be something else also. Come on, bacha, come on, quickly. Tell me. What is E? What is E? Value. Tell me the value. Tell me the whole value, Army of God, Praveen Kumar, come on, you know the answer. 1.6 into minus 19. Okay. Now, let's solve it. Yes, minus 9, minus 19. From here it will go, so 19 plus 9, 28, here it remains minus 6, yes, then this will also get cancelled. If you solve it, if you completely solve it, you will get 4.14 electron volt, yes. Now what we have to do is, we have to see that which ones are lesser than 4.14. Which ones are lesser than 4.14, and we see that it is, the answer is 4, these ones, okay. Lithium, sodium, potassium and magnesium, they have lesser than 4.14 volt. So the answer will be 4. I think it is written in options, okay. I think there were options here. So this will be your answer, and you have to answer in integer form, okay. You have to answer it in integer form. This has come in AIEEE 2011 and the answer is 4. Okay, now answer is 4 bacha. 4, no? See, 3.17 is also lesser than 4.14, isn't it? 3.17 will also be lesser than 4.14, exactly. So this is your answer. Acha, now tell me. The de Broglie wavelength lambda associated with a photoelectron varies with frequency nu of the incident radiation as V0 is threshold frequency. Tell me, what will you do? Yes, Rex Knight, energy has to be greater than work function. Absolutely, yes. Hanji, go ahead, let me know. Option 3 or option 4? Option 3 or option 4? Cycle riders, please watch it from the beginning, bacha. I had told you the formula, huh? I had told you the formula. Acha, don't you think that there will be a root over? There will be a root over. Don't you think that it is option 4? Lambda is directly proportional to 1 by V minus V0 to the power half. Right? It will be root over. There will be root over. That is why. Chalo, let's solve it here. See, de Broglie wavelength lambda for electron is, remember, lambda is equal to h divided by root over 2m ke. And according to the photoelectric effect, we know that kinetic energy ke is equal to hv minus hv0. Now, when you substitute the value of ke in equation 1, what will you get? You will get lambda is equal to h by 2m into hv minus h0. Take this out, h will cancel, 1 by v minus v0 to the power half. So that means option 4, right? Option 4. Clear? Is this understood? Is this understood? Now we will do more problems later. But shall we go to the next chapter, guys? Shall we go to the next chapter, or do you want a break before this? Or do you want a break before this? I also do want to go to the washroom. So can we take a break? But I need you all to call your friends, yeah? Why nobody is coming? Huh? Already 1 hour. We will go to the next chapter, but let's take a 2-minute break. 2-minute break? And no, 5 minutes, yeah. 2 minutes break. What's the time now? What's the time now? The time is 15:13. We will meet at 3:15. 3:15 we will start again, okay? I'll just be back from the washroom, okay? Yeah, I'll just be back from the washroom. Till then, just call up your friends. Wake them up, okay? Wake them up. Chalo. See you in a bit. All right then. Yes, break is over. Another hour, another chapter. Yes. Chalo. Those who left the class, do call them also. They'll be at loss, guys. 3 chapters. You didn't prepare, no problem. We're going to get you prepared now. 1 minute later. Aha. What to do? Chalo. Okay. Yes. So let's start with periodic properties of elements, and you know, bacha, that once you learn periodic properties of element, how is it going to help you? It's going to help you with the block chemistry like S block, P block, D block, F block, all of that you will be able to learn properly. Yes, so that is why it's very important that we understand periodic properties of elements. And do you know what is the weightage of periodic properties of elements? 9.9%. Chemical bonding has 6.6%, atomic structure has 6.6%. Like I said, 25% weightage of overall chemistry paper is getting completed today. So I don't know what you guys are doing. I would hope that all of you has to come here, yes? Out of 100, no, out of chemistry portion. Chemistry portion is what? 40% of the chapter around, right? Or 33% of the chapter around. So out of that 33%, 25% is only done, okay? Overall, bacha, overall, everything. This is what? Inorganic and physical chemistry. Atomic structure and chemical bonding, they belong to physical chemistry. This is inorganic chemistry. Periodic properties is inorganic, but atomic structure and chemical bonding, they belong to the physical chemistry part, isn't it? I'll be taking care of this thing also. Enough? No. 3 years? No. No. Go beyond 3 years. 5 years. 5 years, 10 PYQs, mock test, all of these are important, bacha. Just one thing, how can it be enough? Yeah. Yes, I will give you short notes. I'll give you this whole PDF. No, this whole PDF is basically short notes. Yeah. This whole PDF is basically short notes. Okay? Chalo. Alright guys, focus up. Let's begin. Periodic properties of elements. Now in periodic properties, where do we start from? We start from periodic table of the elements. This right in front of us, this is your periodic table. In this periodic table, we see that on our left hand side we have our S block, on the right hand side we have our P block, at the center right here we have our D block, and here it is, okay, here it is our F block. But I just started today. Yes, give me some time, give me some time. It takes a lot of time to prepare also, right? Yes, 3 chapters in a day, it's not easy. I also have to prepare before I come. It's not like I just get up in the morning, brush my teeth and come take classes. I can't do that. Yeah. You can't do that. Yes. I'll give you the chapter, I'll give you the questions. Don't worry. From today, you will get it in the Telegram channel. So do join the Telegram channel also. Okay. Okay. Chalo. Yeah. So like I said, you have S block here. Let me write that down. I think that's better if I write it down. I hope you haven't forgotten it. Ha. So this is our S block. This is our D block right at the center. This is our F block, and here is our P block. Yes, and this is overall our periodic table. Now in this periodic table, the S block has 2 groups in it, group 1 and group 2. Yes, alright. Yes, you can see this for NEET also. Hana, P block has group 13 to group 18 is considered in P block. Yes, group 18 is a noble gas and we study them together here in P block. Group D or D block, okay, D block, they are also called as transition elements. However, as we learnt that zinc, cadmium and mercury, they are not considered as transition element, but they are your D block element when we will study them in the D block elements, D and F block when we do it, okay. F block is right here. It starts from atomic number 57 and it goes till 103. Till 103, it is your F block elements, okay, as F block element. Now, moving on from here, basically what happened is, why did we have a periodic table? Why is it called as a periodic table? Have you ever thought, why couldn't we just call it as table of elements? We could call it, right? Right? Life could have been easier. Why did we start calling it periodic table? Because we saw that the elements had properties that were repeating at a certain period, okay. The elements had repeating properties that were coming up again and again after a certain interval, a certain period of interval. And that is why we started calling it the properties that reappear at regular intervals, yes, or in which there is a gradual variation at regular intervals are called periodic properties. Hey, you understand what is periodic motion, isn't it? What is periodic motion? Pendulum. Tick, 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 tick. That's periodic motion. You get up on a swing and you go forward, backward, that is also what? That is also a periodic motion. The moon revolving around the earth, that is also periodic motion. And just like that, when here the properties, they reappear at regular intervals, reappear at a certain period, okay, period of interval, we call it periodic properties, which is what happened with the elements also. Now, in case of periodic properties, these are our properties: atomic radius, valency and number of valence electron, metallic and non-metallic character, ionization energy, yes, electron affinity and electrovalent, okay, electronegativity. You finish mole and equivalent, no prince, it's tomorrow, coming up tomorrow. Haven't you noticed the community post? In the community post, we had posted, no? We had posted the timetable. Today we are doing 3 chapters. Tomorrow we'll be doing another 3 chapters, okay? If you want, I'll show you this thing again. Don't worry. I'll show you the property. The timetable. I'll show it to you. So these are our periodic properties that we have to note. Yeah, that we have to study. Now, what is atomic radius? What is atomic radius? Atomic radius of dihydrogen, H2 molecule. What is atomic radius? My dear student, an atomic radius is basically half the distance. Can you measure atomic radius? Like, can you just take one atom and measure the radius? Not possible. It's not impossible at all. Which is why we consider 2 atoms to be there. Okay, we consider 2 atoms to be there. And what we do is we measure from one nucleus to the second nucleus and then halve it. Yes, we measure the distance between one nucleus to the second nucleus and then half of the distance between the adjacent atoms of the same element in a molecule. That is called as atomic radii. Now, what is the trend here? What is the periodicity? What is the periodicity of atomic radius? We see that decreases from left to right. As you go from left to right across a period, atomic radii decreases. Why? We will be answering it in the upcoming slides. Okay, we will be answering that in the upcoming slides. Now, it increases from top to bottom within a group. As you go top to bottom, you see that atomic radius increases. It increases. Why? Number of shells also keeps increasing. Number of shells also keeps increasing, which is why atomic radii increases. But as you go from left to right, it decreases. All right, moving on from here. Valency. What is valency, my dear student? Valency is basically the combining power. Now, we know, do you remember that each and every atom, just like how we do, right? We have this innate nature of getting stability in our life. That's exactly why we study. That's exactly why we want stability in our job. That's exactly why we get married, right? That is exactly why we buy a house, because we want to stick to one place. We want stability in our life, isn't it? Yes? And what is stability? This stability is finding a partner, finding a good job, finding a good college, finding some great money, finding a great house. These are all our stability perspectives, isn't it? The same way, exactly, an atom also wants to behave like a noble gas. Like noble gas is their ideal gas, right? They are the ideal elements. They want to look like them. They want to behave like them. Like for me, why do I want that? Why do I want that stability? Because I see Ambani and I feel like I want to earn that much money someday. Right? I want to behave like them. I want to have that lavish life. I want to have that Ferrari car or my own jet which I can travel anywhere, everywhere, you know, whenever I want to. That's my idol. I want to behave like that, and that's exactly why I want to work harder. The same way, the atoms, they see noble gases and they want to behave like them, they want to look like them, which is why they want stability in their life, and their stability is 8 electrons. And to get that 8 electron, they combine. Yes, they combine in certain capacity. Now, everybody cannot do that, right? Everybody will not be able to work hard the same way. I mean, I will probably not be able to work hard the same way as Shreya sir is doing. Because Shreya sir right now is taking care of physics and mathematics. You ask me to take physics and mathematics, I'll be like, oh, maths, I'll sit and cry. I can't do that. So everybody has a different combining capacity, and that combining capacity is your valency. Yes, correcto, clinical, clear, understood? Yes. Now moving on, the electrons that are present in the outermost or the valence shell, the last shell, okay, of an atom, they are called as valence electrons. They are called as valence electrons, isn't it? For example, if we take chlorine, chlorine has atomic number 17, symbol is Cl, yes. Now valency is 1. Because in its outermost shell, it has 7 electrons, my dear student. If it has 7 electrons, do you think that it can go beyond 1? No, it only needs 1 electron. 1 electron only to attain its octet configuration. Yes, 1 more electron, it will have 8. So that's its valency. Am I clear, everybody? Am I clear? Yes. Now, valency, what happens is, it first increases and then it decreases as we go from left to right in a period. And it remains the same in a group. Acha, chalo, let me give you a trick here. How will we find valency? See, how will we find valency? Group 1, valency is also 1, okay? Group 1, valency is also 1. Let me write this with blue color, hai na? Group 1, valency 1. Group 2, valency 2. We will leave this part, then we will come here. Group 13, valency 3. Group 14, valency 4. Now you subtract. Here again 3, 2 and 1. This is our valency. Can we remember this trick? Can we remember this trick, everybody? Is this clear? Group 1, valency 1, group 2, valency 2, group 13, valency 3, group 14, valency 4, and then 3, 2, 1 again. So like I just said, what is the trend that I told you? The trend is that valency first increases and then it decreases as we go from left to right in a period. Now in the group it remains same. In the group it remains same. Can we say easy peasy biryani is tasty, everyone? Is this easy peasy biryani is tasty? Awesome. Now, number of valence electron, it increases. Acha, we have spoken about it. Now we go to the metallic and the non-metallic character. Okay, what are metallic and non-metallic character? Let's understand. So, the metallic character is the tendency of an element to lose electron. Losing an electron is dedicated to a metallic character. Okay, is dedicated to metallic character. You have seen, right? Sodium. What does sodium do? Lose an electron. Have you seen manganese? What does manganese do? Mn plus 7 oxidation state. 7 electrons it can lose. Yeah. So losing an electron is always synonymous to metallic character, whereas non-metallic character is gaining an electron. What does Na do? Na loses 1 electron, Cl takes in 1 electron and they form a bond. Yes. So what happens to the metallic character? We see that it decreases from left to right. The left ones, what are the left ones? The alkali group and the alkaline earth metal. Alkali metal, alkaline earth metal. Naam mein hi metal hai, isn't it? In the name only they have metal, so obviously they are metal. But as you go towards the P block, you see that P block has majority non-metals and some of them are noble gases also. Yeah, so that's what? From left to right as you go, what happens? The metallic character, it decreases. But it increases from top to bottom along a group. If you go down the group, you will see that it increases. Alright? Yes. Now, the non-metallic character, it relates to the tendency of accepting electrons, obviously, during a chemical reaction. So what will happen to the non-metallic character? It is absolutely opposite of the metallic character. As you move in a period from left to right, what will happen? It will increase. The non-metallic character increases and the metallic character decreases. Am I right, everybody? Yes? Understanding? Hey guys, why do I see that you are leaving the class? Huh? What did I tell you? I told you to stick to the end of the class. Only then you are getting the 25%. Not interested, huh? Don't want to get marks. Yo, guys. I can see that many of you are leaving. I'm not liking this, huh? Not liking this. Go call up your friends. Tell them that ma'am is asking you all to be here. You leave the class, you're not getting this. Hannah, we will be there. Thank you so much. Sweetheart, Siva. What can I do about them? Yeah, you can't do anything about them. Chalo, theek hai. Alright, Now, what is ionization energy? Ionization energy, how many of you remember that? We need questions, bacha. Ha, bacha. You know what? I think today I anticipated, I thought that because the class will be too long, it will go till 5 o'clock. So I did not bring too many questions. But guess what? I'll give you more questions. I'll give you an assignment in the Telegram channel also. And from tomorrow, I will bring in more questions, okay? I'll bring in more questions. Yeah. Done deal, guys. Pakka se done deal. Yeah? I'll bring in more questions from tomorrow. Noted, point noted, my mistake. I should have brought more questions, but today there are less questions. Don't worry, I'll give you more questions in the, I'll give you more questions as assignment in the Telegram channel. Alright, chalo, moving on. What is ionization energy? I hope you remember that example, yeah? I hope you remember that example. So you know what, I kind of stopped shopping because I found out that I'm a shopaholic and I really do shop a lot. Like every month I'm spending at least 10,000 rupees on shopping, and I think that's not a very good idea, yeah? Why spend only on clothes? I should rather buy gold and diamonds now. Anyway, coming back to the point. So when I shop, what am I doing? I know I'm getting some clothes, right? My wardrobe is getting filled. Absolutely, yeah. Absolutely. And that is providing me, pumping some dopamine into my system. And for that time, I am definitely happy. Yeah, I'm dancing. Every time the parcel comes, I'm like, woohoo, another parcel, right? But then what am I losing? I'm losing money. I'm losing money, and that's not a great sense of investment, yeah. If you know about investments and if you know about, diversifying your wealth and increasing your wealth and all of that stuff, you understand that you have to increase your wealth and not just reduce it. So when I'm spending money on my clothes, I'm actually reducing it because clothes don't matter so much, yeah. Now, the very same way, just like how you saw that for me to get my shopping cart, to get those things that I wanted, I had to lose some energy. The same way everyone, what happens to an atom? The atom will only be ready to give away its electron when you provide energy. Otherwise, the atom is like, good luck with it. Without energy coming to take my electrons, not possible, not giving it to you. Like imagine if I go to Myntra and I'm like, Myntra, please let me shop, yeah. Max to max, Myntra will provide me some discount, yeah, 70%, 80% discount, but will it give it to me for free? No. Good luck, daydreaming to me. Same way, whenever you want to take away one electron from an atom, you have to give some energy. And that energy that you give it to the atom to take away its electron, that, my dear student, is your ionization energy. Is that understood? The story is understood? Yes? The story is understood, everybody? Great. So the minimum energy that is required to remove the most loosely bonded outermost shell electron in the ground state from an isolated, Now if it is bonded, can you take away electron? It's already bonded. Octet rule is figured out. It's stable. It will not give away. You will have to take the atom to its gaseous state, and in an isolated form. It cannot be bonded. It has to be unbonded, isolated, single, and in gaseous form. Only then you can take away its electron. Only then you can take away its electron, isn't it? Yes. So this is known as ionization energy. So if something is in gaseous form, you will give them some ionization energy and you will take away its one electron. So that means it has a positive charge. In gaseous, you have taken away one electron. That is what is your ionization energy. How many of you understood it? Can I get some la 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 in the chat box? Yes, I'm going to do that, but you tell me how many of you understood it, guys. Amazing. Okay. Great. Thank you so much for reminding me. Now, moving on. Ionization energy. What's the trend? The trend is it increases across the period. As you keep going this side, it increases, okay? It increases. You see, no, these guys, they want to take one electron, isn't it? They want to achieve one electron. They don't want to give away their electron. These guys are very famous for that. They want like a Leja. What do they remember? These guys, they remind me of that song called Leja Leja Re. Remember that song? In Hindi, there is a song. In English, I can't remember. Anyway, so these guys, they want to give away electron, but they don't. They want to take an electron. So what will happen? Ionization energy will increase. Yeah? Because they don't want to give their electron. That's it. That's the trend. And it decreases down the group. As you go down the group, what will happen? Size increases. As you go down the group, the size increases. The size increases from the nucleus. The electron is very far away. So, whoop, you can take away the electron easily. Give space, live in space. How long the session will go? I think it will go till 5 p.m. at least, okay? Till 5 p.m. at least, yeah. Okay, now, what is electron affinity, guys? What is electron affinity? So, the amount of energy that is released when an electron is added to the valence shell. What is affinity? Affinity means love, okay? Affinity means love. Like for example, let me say this example. I have a certain affinity towards coffee and not tea so much. That means that I like coffee more than tea, right? The same way, electron affinity means how much does an atom love the electron that it will take it in, okay? And when it takes it in, now what is happening? Ulta of ionization energy, opposite of ionization energy is happening. In ionization energy, it took away the electron, gave it energy, right? Here what is happening? You give one electron, it will release energy. Yes, it will release energy. Understanding, everybody? So the amount of energy released when an electron is added to the valence shell of an isolated gaseous atom is known as electron affinity. Yes, so X, any gas, okay, any gas, when you add an electron, it will become electronegative, X minus, right? It is becoming, see, X minus, and that, my dear student, is your electron affinity. Understood? Is this clear? Is this clear? Gautam, are you asking me? How old am I? Why, yeah? People say no. Yes, this is also electron gain enthalpy. People say that you shouldn't ask the girl's age, yeah? You shouldn't. That's what they say, although I'm not very shy about it, but yeah, I'm 29-year-old, if that's what you wanted to know. Which electron has more energy, inner or outer? Gautam, babe, or bro, you tell me, huh? You tell me which one will have more. You think about it. Anyway, acha. Now, what happens to electron affinity? It generally increases across the period. As you go across the period, you see that they want to take in more electron. Obviously, these guys, they give electron. These guys, they want to achieve more electrons. So, electron affinity increases, okay? And generally, it decreases down the group. Obviously, the size increases. They can lose an electron, but to take, they're like, no. That's what they're going to do, okay? All right? Get it? Clear? Awesome. Now we come to electronegativity. What is electronegativity? Achha, so this is one property, okay? This is one of the property. Now we are talking about a bond. All of these time we were talking about a single electron everywhere, but this is a bond, okay? This property is related to bond. So the tendency of a covalently bonded atom to attract shared pair of electron towards itself is called electronegativity. I'll give you the same example. Who are the teachers in this channel? You have Shreyas sir, you have me. What is Shreyas sir doing? Shreyas sir is pulling the load of physics and mathematics and running the channel. What am I doing? I'm going to take care of the chemistry, whole of chemistry, organic, inorganic, physical, right? I'm going to take care of chemistry. Shreyas sir is going to take care of 2 subjects. Huh? Yes? Yep. Yes. Now, what is it? Both of us are sharing the load of this channel. Huh? JEE English is running because of Shreyas sir and me, right? Both of us are sharing the load of the channel. Now, who is taking care of the load a little too much? Shreyas sir. Who is doing it less? Me. I'm only taking care of chemistry. I mean, the whole of chemistry, yes, but I am taking care of the whole of chemistry. Shreyas sir is taking care of physics and mathematics. That means that the shared pair of electron. Who is the shared pair of electron? The channel. JEE English. JEE English is towards Shreyas sir a little more. That means electronegativity is towards Shreyas sir a little bit more. Understanding? Yes, understanding. So that means who is more electronegative? Yes, who is more electronegative? Shreyas sir is more electronegative. Huh? Cool? Easy example. Easy peasy biryani is tasty. Do we understand electronegativity now? Do we understand electronegativity now? So if you take a look at HCl, what is happening? Cl has this. Cl wants to take away the bond a little more towards that side. Yes, Cl wants to take away the electron, take away the bond a little towards that side. So this is the thing. This is the thing. That's it. That's it. Yes. I know, Arun, Capto. So you have Capto and Nobita ma'am, right? Yes, and answering to the question, where is Wasim sir? Still in Vedantu, but bacha, as you know, he is a part of NEET English, he is a part of NEET Made Easy, and then JEE English. It becomes a little too much for him, yeah? How many class can a person even take, right? So it becomes a little too much for him. So I'm stepping in, I'm helping him. Whenever he can, he will definitely come to the channel and take care of your doubts or whatever you have, okay? He will do that for you, don't worry. Logan, not just Nobita, no, call me Nobita ma'am, huh? Yeah, okay. Now moving on, what is what is the trend for electronegativity? Yes, the trend for electronegativity is it increases across the period, decreases down the group. What are you asking? Ma'am, electron affinity is opposite to ionization energy, but trends are same. Yes, bacha. Why? Why is trend same? You have to understand that this side of the periodic table, they want to take one electron, right? So obviously it will increase, but this side they don't want to take the electron, isn't it? They will rather, what will they do? They will rather give away their electrons, isn't it? Now what is ionization energy? Ionization energy is giving away one electron. So these fellows, they can easily give it. So that means their ionization energy is less. But these fellows, they don't want to. So their ionization energy is more. Do you understand the logic behind it, the common sense behind it? Yeah. Yeah. Easy peasy, biryani is tasty. Now finally, if we want to take a look at all the trends in 1 minute. Okay, I'm going to make a short out of this. Yeah, I'm going to make a short out of this. See, take a look at it. This is all the trends in 1 minute, everybody. Let's do it. Atomic radius decreases down the group. Okay, atomic radius decreases down the group. No, increases down the group. Okay, atomic radii increases down the group. Ionization energy increases from left to right. Electron affinity increases from left to right. Non-metallic character increases from left to right. Metallic character decreases from left to right. Okay, all right. Did you write JEE where? Atomic radius is the opposite. See, only atomic radius increases towards the left side. Okay, only this is opposite. Atomic radius is opposite. This question has come a lot of times. This question is very simple, very easy, but it has come a lot of times. Electron affinity, as you can see, ionization energy, as you can see, all of these I have just told you. Okay, yes. All right, everybody, are we clear with these properties? Shall we do a question? Let's do some questions. Let's do some questions, guys. Yes. Okay. So the ionic radius of Na plus, okay, Na plus ion is 1.02 angstrom. The ionic radii in angstrom of Mg2 plus and Al3 plus respectively are. What is the answer? Go. What is the answer, guys? Come on, tell me the answer, everybody. The ionic radius of Na plus ion is 1.02 angstrom. Use your common sense, okay? Use your common sense and you will understand this. Very easy. So if it is Na plus is 1.02. Na plus is equal to 1.02 angstrom, right? Mg2 plus, that means it has already lost 2 electrons. If it has already lost 2 electrons, then it will even be closer. 2 electrons are gone. Now the Z effective, the effective nuclear charge has increased, so the nucleus is going to pull the atom closer to it. That means Mg2 plus will be lesser than 1.02 angstrom. It will be lesser than 1.02 angstrom. Now going to Al3 plus has lost 3 electrons, my dear student. If it has lost 3 electrons, that means it will be even lesser. The atomic radius will be even less. So not atomic radius. Ionic radii will be even lesser than before. Yes. Why even lesser? Because 3 electrons it has given. Z effective increases. Effective nuclear charge increases. The nucleus will be easily be able to pull all the electrons closer to it. That means that it will be even lesser, which means that option number 2 makes sense for us. Yes. Otherwise, anything else that makes sense? It does. Option 1 also does, but it cannot be more than 1.02. See, it cannot be more than 1.02 because Na plus already has 1.02. Now 2 electrons lost, it will have to be lesser than it. Yeah, correcto? Great, awesome. Next question. In general, the property, okay, magnitude only that shows an opposite trend in comparison to other properties across a period is, see, JEE Main 2020. Can you imagine what an easy question it is? What an easy question it is, but it still has come. It still has come. Of course, yes, atomic radius. Atomic radius is the correct answer. Very good. Absolutely yes, my dear student. Moving on, moving on, moving on. The element having greatest difference between its first and the second ionization energy is. The element having greatest difference between its first and second ionization energy is. Batao. Tell me guys. What is the answer? A no, Shruti. How can it be 2? Why will it be scandium? Huh? Scandium actually shows +3 state if you remember. Scandium actually shows +3 states. So the first 3 electrons, losing first 3 electrons is very easy for it. That cannot be the answer. Ah, it has to be potassium. Why potassium? Acha batao. What is the atomic number of potassium? What is the atomic number of potassium? What is the atomic number of potassium? Bolo. A. K plus 1. Are? Oh, look at you guys. Chalo, we'll do it. 19. Very good. Yes, 19. Hai na? If it is 19, chalo. Now let's see. What is the electronic configuration? 1s2, 2s2, 2p6, 10 done, 3s2, 3p6. Yes. Then 3p6, 4s, 10, 11, 12, 13, 14, 15, 16, 17, 18 and 9. 4s1. Ha. Now see, very easily it will be able to lose this electron, isn't it? Very easily it will be able to lose this electron because only one. If it loses, now what will happen guys? 18 electrons. This is a noble gas configuration. This is a noble gas configuration. 6 is fully filled. This is fully filled stability. Yes, fully filled stability. Now do you think that it will want to lose the second electron? Now do you think that it will want to lose the second electron? Not at all. It doesn't want to lose the second electron, which is why the difference between the first ionization energy and the second ionization energy is a lot more. Clear hai? Clinical clear? Yes? No? Very good. Yes, absolutely right. ठीक है. Moving on to the last chapter, chemical bonding. Shall we start, guys? Already my back is aching now. Shall we do it? Yeah? Chalo. All right. Once again, this is very important. Do you know what is the weightage of this 6.6% of the questions? Okay, 2 questions definitely from this chapter, they always do come. 2 questions will definitely come from chemical bonding. Okay, chalo, moving on everyone. Chemical bonding, let's start. Now in chemical bonding, the most important theory is VSEPR theory. Before that, do you all know what are the different kinds of bonds that you have? You have ionic bond, you have covalent bond and all of. Shivi, I think we just have another hour. Let's finish it. Let's finish it and then we'll take a long break. After that, you will have to take a break of like 5 to 6 p.m. and then you can do your self-study, isn't it? Let's finish it, guys. है ना? Let's finish it. Chalo. Everybody with me on the same page? Yeah? Wake up, guys. Wake up. Wake up. Wake up. Wake up. Chalo, let's do one thing. Let's clap for a bit. Clap for a bit so that you all wake up. I want you all to wake up. Yes. Very good. Clap, clap, clap. Everybody wake up. I want you all to wake up. Woke up? Awesome. You guys drink a little bit water. I will also drink a little bit of water. Let's freshen up, everyone. Freshen up. I want some clap emojis also. How will I know that you are clapping, huh? I have no way to see you. That's my bachas, yeah. That's my bachas. My champions. Absolutely right. Amazing. Ha. Where are you from? Come to Alapura. You have exam, Badmash. Hey, Badmash. One punch you will get. No. One punch you will get. Huh? You have JEE exam from April 6th. Now you want me to come to Alapura? Shh, focus. Chalo. Okay. Chemical bonding, let's start. Now, VSEPR theory. Who can tell me the full form of who can tell me the full form of VSEPR theory? What is it? What is it? What is it? Gautam, in JEE, no, they will not ask about me. They will not ask about me that which college did Nabamita ma'am study in, how much marks she get. They will not ask you this. So let's focus here about me later. Huh? And if you really want to know about me, you follow me on Instagram, Nabamita_Nobita. I'll tell you there, okay? We'll talk there. Very good. Valence shell electron pair repulsion. Absolutely right, yes. Valence shell electron pair repulsion. So what does this theory tell us about? What does this theory tell us about? Now this theory says that the shape of a molecule, no, it always depends upon number of valence shell electron pairs. It can be bonded, it can be lone pair, okay? It can be bonded, it can be lone pair. Basically, whenever there are bonds created, be it lone pair, be it bonded, be it non-bonded, all of them have certain bit of repulsion. Yes? Who are bonding? Electrons are bonding. All the electrons, they have negative charges, negative charges, negative charges. Right? Now what will happen is whenever they have bonded, because of the electron cloud overlapping and all of these, there will be repulsion. After all that repulsion also, whenever they have a stable molecular formula, whenever they have a stable, yes, after all the repulsion, however they stay the most stable, that is what the theory speaks about, okay? This theory says that the shape of a molecule depends upon the number of valence shell electron pair. It can be bonded, it can be non-bonded around the central atom. Now the pairs of electrons in the valence shell, they repel one another since their electron clouds are negatively charged. Exactly what I told you right now. Yes, whatever I told you. So these pair of electrons, they tend to occupy such position in space that minimize the repulsion. Achha, tell me something, okay? Have you noticed that, especially my mom and dad, yeah? My mom and dad, when they made the house, they made sure that me and my brother, right? I have a sibling, I have a brother, younger brother. We fight a lot. We fight a lot. So what they have done is, very chalu, very chalak bro, chalak. My mom and dad, what they did was, they thought that these two, they cannot have their rooms next to each other. Because these guys are gonna fight so much that at night, maybe one will murder one will murder the other one, or we will not be able to sleep. So what they have done is, there is my room, then parents' room, and far away is my brother's room. So this is the distance that we are maintaining. This is the distance that we are maintaining. At this distance, at this position, the repulsion is also minimum. We are fine with it. We are stable. The household runs stable. No fight at night. Both sleep together. I mean, both sleep at each other's room. Yes, yes. Because in between there is mom and dad, or mom and dad's room also. Yeah. So minimum repulsion. We are fine with it. We are fine with it. And that is VSEPR theory of my home. Yeah. Anyway, now coming back to VSEPR theory of our electrons. Now these pairs of electrons, they tend to occupy such positions. They tend to occupy such positions so that in the space, the minimum repulsion and maximize distance between them. That was the maximum distance between me and my brother, and that minimized the repulsion. We are fine. Now we can talk. Huh? Got it? Awesome. Now, a little bit more text, guys. I understand it's a little boring, but don't worry. Molecular orbital theory is very interesting, yeah? So, the valence shell is taken as a sphere. What do? We consider the valence shell to be sphere, okay? With the electron pairs localizing on the spherical surface at maximum distance from one another, yeah? At maximum distance from one another. What did I say? We consider the valence shell as a sphere with electron pairs localizing on the spherical surface at maximum distance from one another. Now, a multiple bond is treated as if it is a single bond. Catch. This is the catch. multiple bond is treated as if it is a single electron pair, and the 2 or 3 electron pairs of a multiple bond are treated as a single super pair. Gotcha? Understanding? Understanding? Yes. Now, where 2 or more resonance structure can represent a molecule, the VSEPR model is applicable to any such structure. Anyway, now in case of VSEPR theory, what do we understand? We understand that a lone pair repulsion will be the maximum. Then comes lone pair bond pair, and then comes a bond pair. So the repulsion between a bond pair is the minimum, but the repulsion between a lone pair is the maximum. Now you check it out here, guys. Okay, H2O, water. What does water have? Water have a bent shape. Why? If you see, there are 2 lone pairs here, there are 2 lone pairs here. Now, because of this 2 lone pair, there will be repulsion. See, lone pair, they will repel each other a lot. Now, because of their repulsion, what will happen? This lone pair and bond pair, they will also repel. This 2 will also repel. But these 2 will have minimum repulsion. So, they will come closer. Yes, they will come closer. See, these 2 have come closer. These repulsion was a little bit more, but this repulsion was also quite to certain extent, but here the repulsion was minimum. So they came closer. They will repel, but the repulsion is lesser than the lone pairs of oxygen. है ना, Rexnite? Yes. Yes. Understanding. Why is BP less? Ayye. Bacha. How many more? There are more electrons. These, I mean, this is the foundation of VSEPR theory. Gautam, JEE exam you have to give, bacha. What are you asking me now? What are you asking me, bacha? They always do that. You have to understand this, okay? Anyway, chalo, moving on. So the repulsive interaction of electron pair, it decreases in this order. This is the order, okay? This is the order. Gautam, can we do this a little later? Can we do this a little later? Let's understand this. This session is more about your tips and tricks, no? We'll come back to that later. You know what? Let me do one thing. You write the same doubt in the comment section. Write the same doubt in the comment section after the class. I'll explain it to you, okay? I'll explain it to you. No problem. Chalo. Chalo. Moving on, okay? We have understood. Now, the geometry in which the central atom has no lone pair of electron. The geometry in which the central atom has no lone pair. We are talking about the normal scenarios, absolutely normal scenarios, okay? So in this, what happens is, you will see that the molecular geometry remains the same as the arrangement of electron pairs, okay? Take a look at it. So if there are number of electron pairs 2, okay? No lone pair, only bond pair, yes, see? The arrangement of electron pair linear, molecular geometry linear. What are the examples? The examples are BeCl2, HgCl2. If the number of electron pair is 3, then you will get a trigonal planar. In a plane, they will act like a triangle. In a plane, they will act like a triangle. Now, their molecular geometry will also be trigonal planar. Yes. Now, if the number of electron pair is 4, no lone pair, then it will be a tetrahedral, okay? The electron pairs, they will have a tetrahedral, okay? And the molecular geometry is also tetrahedral. Yes, moving forward, if there are 5 electrons, then it will be trigonal bipyramidal. You will see protrusion on both the side, bipyramidal, okay? Here also it is trigonal bipyramidal. Now, if it is 6, then it will be octahedral. Again, molecular geometry is also octahedral. Now, moving on to 7, it is pentagonal bipyramidal. It will be like a pentagon, and then this, and then it will be what? And then it will be pentagonal bipyramidal. 2 sides there will be protrusion, so pentagonal bipyramidal. Alright, yes, what is the example? IF7. Acha. Now, what if there are lone pairs? Now, what if there are lone pairs also? There is bond pair, that means there can also be lone pairs, right? Now, let's understand this. Acha. So, we have molecule type is AB2E. 2 bond pairs are there and there is 1 lone pair, okay? 2 bond pairs are there and then there is 1 lone pair. So, arrangement of electron pair is trigonal planar. Let's understand. Let's understand. See, what do we have? We have SO2 or O3. Okay? So, we have S here. This is our S, okay? Then what will we have? We will have lone pair here, okay, O, right? So, whenever we have to see the shapes of this, okay, whenever there is a lone pair and there is bond pair and we have to find the shape, what will we do is close this. Close this, now see the shape, what will you see? You will see a bent shape, yes? Will you see a bent shape, everybody? Guys, if we close this, if I don't want to see this, if I close the lone pair, what do I see? I see a bent shape, isn't it? And that, my dear student, is the shape, okay? Guys, I will not be able to block him or anything. Can you please block him or report him from your end? And please focus here. If you block him also, you will not be able to see the chat. Let's focus here, okay? Let's focus here. Now, if the molecule type is AB3E, okay? If the molecule type is AB3E, okay? Alright, then what will happen is number of bonding pairs, there are 3 bond pair and there is 1 lone pair. What will we do? Once again the same thing we will do, guys, okay? So basically what will happen is, this is our central metal atom, this is our central metal atom, and then let's draw the other ones also. Let me change the color and let me draw it, okay? What do we have? We have AB3. So we have B and there is 1 lone pair, okay? Now what will happen? What will happen? Again we will close this. Now what do we see? What do we see? We see trigonal, we see, yes, the arrangement of electron pair is tetrahedral, absolutely. It is tetrahedral. But if I close this, don't you see that it looks like a pyramid? It looks like a pyramid, guys, does it or not? Looks like a pyramid. So what is it? And there will also be a protrusion, yes, there is also a protrusion on the top, right? It's coming up from the top, it's protruded. So, trigonal, pyramidal, trigonal, and it is triangle also, see, triangle, but pyramidal, trigonal, pyramidal. Clear hai? Clinical clear, guys? Understanding? Huh? Understanding, okay. Alright, now moving on, AB2E2, that means if there are 2 lone pairs and 2 bond pairs, then what will happen? We will have again bent shape. What is the example? H2O. See, if we have one like this is our central metal atom, and then we have, let's say we have 1 bond here, 1 bond here, and we have 2 lone pairs like this. So what will we do? Again, we will close this. We will close this. What do we see? We see bent shape, 2BP, 2LP. Alright, yes, this is what we get. Correct, guys? Correct? Okay, so we have understood this. Now, AB4E, what if you have 4 bond pairs and 1 lone pair? Okay, for 4 bond pairs, 1 lone pair, what will happen? This will be our central atom, not metal atom, sorry, 2 used to coordination compound. Yes, then we have 4 bond pair and 1 lone pair. What is the shape, guys? What is the shape? Does it not look like seesaw? Does it not look like seesaw to you? It does, right? It does, isn't it? So, see, close this. Seesaw, isn't it? So, what is the shape? The shape is seesaw. Next, AB3ET, there are 3E2, number of bonding pairs 3, yes, and number of lone pairs 2. Now what will be the shape? Chalo, let's check it out. Yes, let's check it out. What will be the shape? We have this, okay, this is our central. This, what did we say? 3 bond pair, 2 lone pairs. Okay, 3 bond pair, 2 lone pair. 3 bond pair and 2 lone pair. Close this. What is the shape, guys? What is the shape? Absolutely right. T shape. Absolutely right. T shape. Are we understanding this? Are we understanding how to find the shape? Yes. Now we will go to 5 bond pair, 1 lone pair. Chalo, let's see. 5 bond pair, 1 lone pair. This 1, 2, 3, 4, and then what will happen is 5 and then 6. So if I close this, what will I get? What is the shape, guys? What is the shape? There will be a protrusion also. Is this seesaw? No. This is square pyramidal. This is square pyramidal. See, it will become a square. It will become a square. And then there will be protrusion as well. So, square pyramidal. है ना? Yes? Okay, square pyramidal. Last one is 4 bond pair, 2 lone pair. Yes, 4 bond pair, 2 lone pair. Chalo, let's make this. Okay. 2 lone pair. Then, what is this? Remove this to what shape is this? Square planar? Square planar? On the plane there is a square. Aha! Amazing. This is your square planar. Absolutely right. Awesome. Okay, so we have understood all the shape, everybody. Yes, do we have we understood the shape? Now we come to hybridization. Acha, what do we understand by hybridization? What do we understand by hybrid? Have you heard about hybrid plants? Have you heard about hybrid plants? Have you heard about hybrid cars? Nowadays there are hybrid cars which can run on petrol, which can run on electricity. That means you have two things. Acha, Liger. Oh, Vijay Devarakonda example, he was a tiger and a lion hybrid, isn't it? Tiger and a lion hybrid. So, Liger he became. Exactly. When two things overlap, when two things come together, that's your hybridization. Absolutely right. Yes, my dear student. So, in case of atoms also, or in case of this chapter chemical bonding also, hybridization means the same. The meaning, the English word hybridization, the meaning of it, it does not change. Okay, it does not change. Why hybridization concept was proposed? Because obviously valence bond theory definitely had certain bit of limitations. Not everything was explained by it, and that means our time was now to move on towards something new, and that's why hybridization came into picture. So in case of hybridization, we understand that basically it is intermixing of the orbitals of slightly different energies. They have different energies. Yes, in reality, S orbital and the P orbital, they have different energy. But we are saying that they will not work like this. They will come together. They will come together and they will hybridize so that they can redistribute their energy, and then they will result in the formation of new set of orbitals of almost same energies, okay? Of almost same energy, and a new shape will also be there, okay? Alright, now that means that, see, when S and P atomic orbitals, when they hybridize, what does it form? See, they are going to hybridize, and this is what they will form. See. This has become longer and they have hybridized, okay? They have hybridized. Awesome. Now, what are the key features of hybridization? Very important. Let's focus here, okay? So, the number of hybrid orbitals, it is equal to the number of the atomic orbitals that get hybridized, right? Once again, what does it say? The number of hybrid orbitals, it is equal to the number of atomic orbitals that get hybridized, not orbital. Yeah. Confusion. Once again. The number of hybrid orbitals, yes, whatever is the hybrid orbitals, what is it equal to? It is equal to the number of atomic orbitals that got hybridized, okay? Number of atomic orbitals that got hybridized, that is what is equal to. Now, the hybridized orbitals are always equivalent in energy and shape. Yes, they are always equivalent in energy. Their energies will be equal, their shape will also be equal. It's not going to be different. We will talk about it in some time. You will see. Very interesting, guys. The hybrid orbitals are more effective in forming stable bonds than the pure or atomic orbitals. Okay, and these hybrid orbitals are directed in space in some preferred direction to have minimum repulsion between electron pairs, and thus a stable arrangement is obtained. Therefore, the type of hybridization indicates the geometry of the molecules. Acha, somebody asked me that, ma'am, why did we have hybridization? But you saw, no, in valence bond theory, how many this thing it had? Valence bond theory had so many limitations. Even in coordination compounds chapter, we have read that, isn't it? In coordination compound chapter, we have read that valence bond theory was not at all sufficing our problems, which is why we had to learn about crystal field theory. And at that time, we kept talking about molecular orbital theory, which is what we are going to read. Molecular orbital theory coming up in the next 2 minutes. Rex Knight, wait up. Hold on your horses. Now there are different types of orbitization. There are different types of hybridization. What happened to me? What happened to me? So types of hybridization, if there is S plus P, S orbital, P orbital, if they hybridize, there is a possibility that it will form sp hybridization, it can form sp2 hybridization, it can also form sp3 hybridization. If it is S plus P plus D, if it is S plus P plus D, then what are the possibilities? We can have sp3D, we can have dsp3, we can have sp3d2, we can have d2sp3. All of these we have studied in our coordination compounds as well. We have, yes. So these are the different types of hybridization. Now valence bond theory, Barkha, crystal field theory we studied coordination compound, it is CFT, crystal field theory, okay. Now to form a covalent bond, how will you form a covalent bond, bacha? What is a covalent bond? Covalent bond is basically the sharing of electrons, right? So when you are sharing electrons, obviously, listen to me. If I want to share my food with someone, I'll share it with neighbor, no? With my neighbor. Do you think that I'll share my food with my Ambani? Will I be able to do it? Will I be able to do it? I won't be able to. Bro, God knows what he eats. Who knows what he eats? And who knows from which 5-star he is ordering? Do you think I can go and give it to him? I'll be like, "Arey sir, fish banaya tha, take it." He will definitely throw it in the gutter, right? But if I give it to my neighbor, they'll be like, "Ayyo nabamita mama, yeah, thank you so much. Yeah, it was very tasty. We loved it." Same energy, no? Same energy, isn't it? Yes? So the overlapping occurs between half-filled valence shell orbitals of the two atoms. It has to be similar. I can't go and reach out somewhere else. Yeah? Isn't it? So in the same atom, SPDF, although energies are little bit different, but when they mix, it is same. It is same, isn't it? Now, the resulting bond, it acquires a pair of electrons with the opposite spins to get stability. For stability, opposite spins are there. One rotates like this, the other one rotates like this, so that stability is maintained, okay? Now, orbitals, they come closer to each other from the direction in which there is maximum overlapping, obviously. Wherever they will see that there can be maximum overlapping, that's where they will come, right? So the covalent bond has the directional character. We will talk about it. Abhi, we will talk about it in just 1 minute, okay? And the extent of overlapping is directly proportional to the strength of the chemical bond. Do we understand this, guys? Is this clear? Is this clear? Easy peasy biryani is tasty, everybody. Yes, is this clear? Valence bond theory, understanding? Great. Moving on from here, now the extent of overlapping, it depends on two factors. There are two things that it will depend on. One is the nature of the orbitals. What is the nature of the orbital? If it is P, D and F, they are directional orbitals. They are directional orbitals, so they have more overlapping. Yes, but when we talk about S orbitals, they are non-directional, yeah? They are non-directional, goal, they're circular, will come, non-directional, less overlapping, less overlapping. Now, if you see, the second factor is nature of overlapping. Either there can be a head-on collision, coaxial, okay, or there can be lateral like this, okay. There can be collateral. It can be collateral like this, or there can be head-on collision like this, which is called as coaxial overlapping. Do we understand this? So these are in coaxial, okay. In coaxial, see, if I hit this thing like this, it hurts more, no, on the knuckles. Doesn't it hurt more on the knuckles? Yes. So the overlapping is also maximum. But when they do this, say it doesn't hurt more. In lateral, yes, the overlapping is less. The extent of overlapping is less. Understanding? So what is the order of strength now? Okay, the order of strength in coaxial overlapping, we see that when there is a P and P, okay, it is more. When there is an S and P, it is a little less. And for S and S, it is the least. Why? Once again, remember, S orbitals non-directional, less overlapping. Clear hai? Clear hai? Great. Now, when two atoms, when they come closer to each other, there is overlapping of atomic orbitals. We have understood. Now, it can be positive overlap, it can be negative overlap, and it can be zero overlap. How? Let's find out. Let's find out. What is positive overlap? See, when the phase of two interacting orbital is same, when the phase is same. Understanding? When the phase is same. Basically, Thaswin, please don't spam, no bacha. I'll tell you when the time comes. Wait up. You have come only right now. You have just said good evening and you have started to spam. Huh? Don't do this. Be in the class. You will get to know all your doubts. Don't worry. Okay. So imagine, see, my head and the other person's head also, if it collides, what will happen? What will happen? Positive or in phase overlapping. But my leg and somebody else's head, it won't hurt so much. It won't hurt so much. So same thing here also. See, positive and positive. Yes, the overlapping. The bond is formed. The bond is formed. The skulls will overlap. It will hit really hard. And it might start bleeding also. Who knows, right? Yes, here. Now, see, this is lateral. Side by side they are doing. This is coaxial. See, head-on collision. Okay. Head-on collision. So you see positive, positive, negative, negative. See, same phase when they're doing. Bond is formed. The bond is formed. But if it is negative, they will cancel each other out. They will cancel each other out, right? If they cancel each other out, then what will happen? The bond is not formed. The bond is not formed. A negative and a positive, the bond is not formed here, okay? And what else can happen is when the orientation of two interacting atomic orbital is such that there is no overlapping of the orbital. Okay, there will be no overlapping here. See, take a look at it. If this is my p bond, okay, if this is my p orbital and this is my x, it will come like this. There is no bond formation. No overlapping. It can't overlap. It can't overlap. It has to overlap like this, right? Yes, it has to overlap like this. But if it comes like this, it cannot. Or let's say that one P is like this and the other P is like this. Now how will it form? How will it overlap? Can it overlap? Is it overlapping? No. So there is where, that is where you get zero overlapping. Is this understood? I hope the hand gestures were easier to understand, right? The hand gestures were easier to understand. So that is where you get zero overlapping, my dear student. Now, so when there is a head-on collision, what do we call it? We call it sigma bond. Head-on overlap, axial overlap, coaxial overlap, that's your sigma bond. Yes, that's your sigma bond. Alright. And here pi bond is when there is lateral or parallel sideways when they're overlapping. That is called as your pi bond. Do we understand this, guys? Is this clear? Is this clear? Yes? Understood? Awesome. Okay. Now let's talk a little bit about the sigma bond. When is the sigma bond formed? I just told you that end to end head-on collision, that is when you get sigma bond. Okay, it is also called as head-on overlap. So remember this sigma. When I make sigma, do you see a head here? Do you kind of see a head here? This is how I used to remember. Because sigma has a head here, so you know that this is your head-on collision. Whenever there is sigma, head-on collision. That's how I used to remember. Now in pi, you see that there are two parallel this thing also, no? When I make pi, see, when I make pi here, see, there are two lines here. So I will write it as lateral. That's how I used to remember, guys. If you want to remember, if you can't, like, there are times when in the exam hall you can't remember, but this is how I used to remember, okay? This is your trick. So pi bond is this type of covalent bond is formed by the sidewise lateral overlapping of half-filled atomic orbitals. Yes, Neetla, what's your doubt? Please tell me. Okay, atomic orbitals of bonding atoms. Understood? Yes. So it can either be like this, or they can also do this, okay? All right. Yes. Got it? So this is your PP overlapping. Two saucer type charge clouds are formed and below the plane, or you can also have something like this, okay? You can also have something like this. Now, combination of orbitals can be SS overlapping, it can also be SP overlapping, and it can also be PP overlapping, which is what we just spoke about, isn't it? This is just summarizing all of it. Now, SS overlapping, see, SS overlapping can be this one sphere, another sphere. When they overlap together, see, when they overlap together, what do? We make two of them come closer. Two of them come closer. So, H, this is what happens. When a hydrogen forms a bond with another hydrogen, this is what happens. Neater. You haven't asked me your doubt, bacha. If you just keep telling me, ma'am, I have a doubt, ma'am, I have a doubt, sweetheart, understand, I'm not God. I can't enter into your head and understand that what is your doubt? Yes, and if you're asking me these kind of stupid questions, do you understand that I'll block you from the channel or I'll lodge a FIR against you? This is a part of cyber crime. Don't you dare do this, okay? Yeah, this is your last warning. Do this again, I'll lodge an FIR against you, and your IP address will be found out from your house and you will go to custody. Does that work when in front of your mom and dad if this happens? Yeah? In front of your mom and dad if this happens, you want to do that? You can continue. I will lodge an FIR, okay? And don't you ask me these kind of stupid questions. Not the place, not the time. Yeah? Chalo. Moving on. Now, when S orbital and P orbital, yes, S orbital and P orbital, do you remember this? If they try to come like this, then the bond will not form. So, basically what happened? The P orbital also has to lie down, right? The P also has to lie down. When they lie down like this, then what will happen? You will have this bond formation, SP overlap this way. Example is HF. Example is HF. Clear? Yes. Moving on. Now, PP overlap, as you just see, PP overlap, see, F and F overlap, this is a PP overlap, alright? Examples I'm just showing you. And now, the hero of our chemical bonding, molecular orbital theory. Let's talk about it. Everybody, are you with me? Are you sleepy? If sleepy, go splash some water on your face so that we can focus here. Yay! We're going to talk about MOT, molecular orbital theory. Who gave it? This was given by Hund and Mulliken. Okay, this was given by Hund and Mulliken. Now, two atomic orbital, they come near. Now, so all of these time we were talking about electron cloud, electron this, electron that, electron this, electron that. We were talking about all of these. Now, do you know that what molecular orbitals say? Molecular orbital theory says that, hey, bonding is happening, a molecule is forming, but a molecule is a different entity. It does not behave like any atom. It's not going to behave like a single electron or anything. It's a different entity. It will behave on its own. And that behavior is what we study in molecular orbital. So, two atomic orbital, they come nearer and nearer, they overlap to each other to form a molecular orbital. Yes? Yes? Atoms come together, they bond. What do they form? They form a molecule, isn't it? Whenever atoms bond together, we call it a molecule. So, this is exactly what is happening. Now, when combination of two atomic orbital happens, okay, it forms two molecular orbital. One atomic orbital plus second atomic orbital, it will form molecular orbitals. Two molecular orbitals. Now, what are the molecular orbitals? One is your bonding molecular orbital and the one is anti-bonding molecular orbital. Yes, one is anti-bonding molecular orbital, right? Two of them are bonding. One will be bonding molecular orbital, one will be anti-bonding. Now, this anti-bonding, it has slightly higher energy. It has higher energy. That means it is also little unstable. Yes, it is also little unstable, right? Got it? So, like atomic orbitals, the filling of electrons in molecular orbital theory is governed by three principles. Auber principle, Hund's rule of maximum multiplicity, and Pauli's exclusion principle. What is Auber principle? Auber principle says that you have to always put the electrons as per their energy level. That is why 1s, then 2s, then 2p, then 3s, then 3p, then 3c. Then what happens? 4s, then 3d. isn't it? You cannot do it otherwise, right? Now what is Hund's rule of maximum multiplicity? Hund's rule says that in none of the two electrons can have the exact same 4 quantum numbers. That means the principal quantum number, azimuthal quantum number, magnetic one, and the spin. They cannot have it all same. And Pauli's exclusion principle, what was that? What was Pauli's exclusion principle? Right? You all know it. You have studied it in the NCERT, isn't it? Now, so energy of BMO, that is bonding molecular, I just told you, right? It is energy of ABMO is greater. Energy of ABMO is greater. Now, combining atomic orbital, yes, should be of comparable energy. Now, molecular orbital says that you can't mix. In hybridization, what did we read? We read that S, P, D, F, they all get hybridized. But what did I say? Remember, I can't go and give Ambani some food, no? I cannot. I have to give food to my neighbor only. Same condition applied here in molecular orbital theory. What it says is that 1s will be bonding with 1s. 2s will be combining with 2s. 2p will be combining with 2p. It cannot be like 1s combining with 2s, 2p combining with 3d. That is not possible. Understanding, guys? Yes. So the combining orbitals must overlap to a large extent, and greater the overlap, stable is the molecular formula. Stable is the molecule formed. Okay. Now, the combining atomic orbitals, they must have the same symmetry about the molecular axis Z by convention. Okay, we say Z by convention. Understood? Yes. Now, linear combination of atomic orbitals, that is LCAO. Yes, LCAO, that is linear combination of atomic orbitals. Nothing but linear combination of atomic orbitals. So basically combination by addition. Same thing, understood? No, constructive interference. Yes, basically if this and this they combine, they will form like this. Okay, but if this and this they combine, they will form destructive interference. Yes, they will form destructive interference. So when the two electron waves are in phase, they have the same sign, they will add up to give a new wave function expressed as psi b. But wave function for bonding molecular orbitals is psi b is equal to psi a plus psi b. This is constructive interference. They are adding up. They are adding up, isn't it? Yes. See how this is forming? This is also positive. This is also positive. Now what happened? It became bigger, right? It became bigger. Constructive interference. Now, if you take a look at the destructive interference, what happens here is combination by subtraction. We combine them, but they subtract each other out. They cancel each other out, right? So, when the two electron waves are out of the phase, that is, they have opposite sign of the wave function, then what they will do is they will combine by subtraction. And the resulting wave function is expressed as psi a, wherein we are subtracting psi capital A minus psi b. We are cancelling it out. Okay, see how it is forming. Now here this was a little bigger, this was also a little bigger because it was opposite. Now here this became a little smaller. Okay, this became a little smaller. Okay, yes bacha. Chalo, it shows much less amplitude. Okay, so wave function for antibody molecular orbital is psi a is equal to, if you can't see this, then this is what it is. Okay, this is the formula that we're talking about. All right. Now LCAO, linear combination of atomic orbitals for homonuclear diatomic hydrogen molecule consisting of A and B atoms. See, each hydrogen atom is in ground state and has one electron in 1s. So psi A, psi B. What will be the atomic orbital? If it is a linear combination, right? We're talking about linear combination. So 1s, another s. They will join. What will it form? See, it will form a sigma. Okay, it will form a sigma bond, head-on collision. It's forming a sigma bond. So psi A plus psi B. But there will also be sigma star, which is equal to psi A minus psi B. Understanding? So there will be bonding molecular orbital and there will be anti-bonding molecular orbital. Am I right? Yes. Am I right? Yes. Okay, now if we do it, see what is happening. This is your increasing order, okay. This is your atomic orbital sigma psi a, you're taking for the first atom. This side is your second atom, okay. This side is your second atom. Now when they will combine, you will have sigma. This has lower energy, so you write it at the bottom. This has lower energy, so you write it at the bottom. This has higher energy, so you write it at the top. Yes, you write it at the top. Okay, got it? So here what will you do? From this you will write one electron. From this, here it will come here. Okay, at the lower energy it will fill up and then this remains empty. Okay. Now basically what we want to say is, so two 1s atomic orbitals, they combine to form two molecular orbital. Bonding molecular orbital sigma 1s, anti-bonding molecular orbital sigma 1s. But how do we write it? Sigma 1s and sigma star s. Okay, all right. Arey nahi, not like that. No, it's fine. Sorry, I was just thinking that let's crunch some time and we will do it faster, because it's what, 2.5 hours already has passed now. That's why. No, I'm fine, Rex Knight. Drank water. Chalo, moving on. Now, what we are talking about is, see, now if 2s and 2p atomic orbitals, what will they give rise to, bacha? What will they give rise to? No, I'm not sad. I'm not sad, bacha. It's not something that is happening for the first time. A lot of students do that. A lot of students come and do all of these things. No problem. This is the difference between, see, where we still haven't reached equality, isn't it? We still haven't reached equality. A female teacher always has to deal with this. Anyway, no problem. So 2s and 2p atomic orbital, they give rise to the following 8 molecular orbitals. What do they give rise to? They give rise to sigma 2s, sigma 2pz, sigma 2px, sorry, sigma 2s, sigma 2pz. Then it gives you pi 2px, pi 2py. Here if you see sigma star 2s, sigma star 2pz, pi star 2px and pi star 2py. Understood? Yeah. Understood? Got it? Clear? Now let's do the final one, that is if there is less than or equal to 14 electrons. For example, let's take the example of nitrogen. Let's take the example of nitrogen, N2. So for N2, what will we get? For N2, what we will get? We will have, let me draw the easier one. Okay. So you will have 1s, 2s, and then you will have is that right? Is that why you will do it? Is that how you are going to do it? Now you can, you can beautify it and draw all of that dot like this, all of that dot like this. You can do all of that, but I'm just going to save some time and I hope that you understand. Okay, so what we're going to do is, from this side there is one nitrogen here and there is one nitrogen here. Okay, this has 7 electrons and this also has 7. So that means 14. All together there are 14, right? All together there are 14, isn't it? Isn't it? So what will we do? We will do 1s, yes, then what? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Done? Done? Now, this part, okay, let me change the color of it, okay. Let me change the color of it so that I can explain it to you. Now, this part remains the same. This part remains the same. But what happens is, these are my stars, anti-bonding molecules, okay. So, this part remains same. What you have to remember is, for less than equal to 14, remember 2, 1, 2, 1. Will you remember this? 2, 1, 2, 1. Okay. This is how you have to draw it, okay. 2, 1, 2, 1. Okay. Understand, this is your molecular orbital. In the exam also you can draw it like this. This is the easier form. Just 1, 2, 3. Just draw the dashes. That's it. Just draw the dashes and that's it. Now, if I have greater than 14 electron, greater than 14 electron, what will I do? 1, 2, 3, 4. Okay, 1s, 1s, 2s, 2s. Now what I will do is, so what I see how it changed, 1, 2, 2, 1. This is what is the change. Now if I take oxygen, let's take oxygen. So 8 plus 8, 16. So that means 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. And now do you see that there are also unpaired electrons? That's why it becomes paramagnetic. Okay. Let me draw the stars here. Draw the stars here. What will I have then? Okay. That's it. Now how do you calculate? What are these numbers that you calculate? What is it? Chalo, I'll show you the formula. है ना? See, if bond order is equal to 0, it means the species does not exist. If the bond order is 0, that means it doesn't exist only. If the bond order is 1, 2 and 3, it corresponds to a single bond, double bond and triple bond. If the bond order is 1, that means single bond. If the bond order is 2, that means double bond. If the bond order is 3, that means there are triple bond. So now if I calculate it for nitrogen, let's see. What will I do? What will I do is number of bonding ones. Okay? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 minus 1, 2, 3, 4. 4 divided by 2. That means 6 by 2 is equal to 3. So that means there are 3 bonds, isn't it? Between 2 nitrogens, there is a triple bond. Am I right? Between 2 nitrogen, there is a triple bond. See how we found it. We found it. Yes. Let's do it for the oxygen also. See. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 minus 1, 2, 3, 4, 5, 6. 6 divided by 2. That means 4 divided by 2, which is equal to 2. Oxygen has double bond. Double bond. See how we figured it out? Easy. Easy peasy biryani is tasty. Abhi to bol do. Now to you can tell no. Easy peasy biryani is tasty, isn't it? Yes. Awesome. Now, if the bond order is more, then the stability of the molecule is also more, but bond length will be less. Okay. And magnetic properties, if all the electrons in the molecular orbitals are paired, what will be? Diamagnetic. If the electrons are not paired, then it will be paramagnetic. Chalo. With this note, guys, we are done and dusted with molecular orbital theory, chemical bonding, structure of atom and periodic property. Let's solve some questions and let's do the, why you put star A? They are anti-bonding molecular orbitals. Anti-bonding molecular orbitals, you must put stars, okay? You must put stars. Nan, I'm so sorry, Shri Suli. Don't mind about it. Yeah, I was little disappointed, but I'm fine. Chill, it's fine. All these things happen, okay? All these things happen. No problem. Chalo, let's solve some question, guys. Let's solve some question. How we can find it? Shivi, I just explained the whole thing. You didn't understand, bacha. I told you, no? For every existing bonding molecular orbital, there is also anti-bonding molecular orbital, okay? How much ever molecular or bonding molecular orbitals you write, that many anti-bonding will also be there. It just depends how many electrons you are filling in all of them, okay? Alright, bacha. I know, Krishna. I know. है ना शिवी? अच्छा बच्चा, don't worry, do me a favor, just watch the last bit of it a little bit, okay? Last bit of it, just pause and watch it again. You will be able to understand, है ना? You'll be able to understand. चलो, let's do this. Yeah, match the list 1 with list 2. Tell me, guys, what is going to happen here? Tell me, what is the hybridization? What is the hybridization? Can we clear JEE if we put in? Of course, yes. Of course, yes. Why not? Aditya, do you see that I'm doing solid states today? Do you see that I'm doing polycentric, monocentric and all of these? No. Huh? Then, tomorrow is your chemistry. Anushri, all the very best, bacha. All the very best. Are you sure? Huh? How will you say that? SF4. SF4. How many will it require, guys? Huh? SF4 will be what? Yes, this will be sp3d. What is IF5? IF5 will be 1, 2, 3, 4, 5, 6. IF5 will be this sp3d2. Now NO2 plus 2, 1, 3, but 1 gone. That means this NH4 plus 4. So that means option 4. Option 4 is the correct answer. Option 4 is the correct answer, isn't it? Yes? Yes, guys? That's what it is. Chalo. Moving on. A central atom in a molecule has 2 lone pairs and forms a single bond. And forms 3 single bond. What is the Krishna coordination compound inner orbital and outer orbital theory? Do you remember? Inner orbital is sp3d, sp3d2. Yes? And outer orbital is outer orbital is sp3d2 and inner orbital is d2sp3. When the inner shell is used, when the orbital of the inner shell is used, that's an inner orbital, and the sp3d2 is outer orbital. Do you remember, Krishna? I've taught you one coordination compound. If not, watch the session. Yeah, watch the session. But anyway, I'll be giving you this thing. No, I'll be taking care of the crash course also. Don't worry about it. Acha. So a central atom, let's draw the structure, guys. There is a central atom, okay? It has 2 lone pairs. It has 2 lone pairs like the Minnie Mouse here. Huh? Looks like Minnie Mouse, no? And then it forms 3 single bonds. So 1, 2, 3. What is the shape? The shape is T-shaped, right? T-shaped. Aha. T-shaped. Woo! We are solving it. We're solving it. Give me a virtual high five. Yeah. Give me a virtual high five. We're solving it. Seems like we're going to clear JEE, isn't it? Okay. Amongst the following, the linear species is. The linear species. Which one has linear species? Come on, come on. O3 won't have a linear species, yeah. O3 won't have a linear species. NO2, see if I draw it like this, N, O, O, there will be a lone pair. Cl2O, right? Cl, Cl, O, this will also have a lone pair. Yes. O3, if I draw, this will also have a lone pair. See, it is not possible. Only N3 will do this. Isn't it? This will be linear. This will be linear. See, only the last one will be linear. So N3 minus, this will be linear. Correct, guys? Yes, bench shape, bench shape, bench shape everywhere. Isn't it? Bench shape everywhere, only this is linear. And with this note, everybody, we are done with the session for today. Okay, we are done. I'm so sorry that the questions were a little less. I will definitely ask ask Bihu ma'am who makes the slides. I'll definitely ask Bihu ma'am to provide some more this thing. Okay? You didn't miss our always. What? You didn't tell about, what did you say? I didn't see your message. What did you say, bacha? Please write it again. Yes, I'll add more PYQs. Absolutely. That's what I'm saying. Acha. Okay. Now, let me show you certain things. Okay. Let me show you certain things. Ha. Acha. So, where do we get the PDF? Where will we get the PDF? Let me show that also. Somebody had written something. Oh, thank you so much. You're so sweet, yeah? You're so sweet. Okay. Ha, got it. Acha. So, where will you get the PDF? Your PDF will be coming here. See? Yes, your PDF. Hey, where is the Telegram channel? Ha, this is the Telegram channel, guys. Just click on this. I'll save it. I'll send you the PDF. Okay. I'll save it. I'll send you the PDF. This is your PDF thing. Now coming back to it, if you have already started with the preparation, you are done with the preparation, definitely most welcome to learn from these sessions. But if you feel like you still need a little more guidance and you want to streamline your study completely, right, then what I would suggest is just for 4,000 rupees, you have JEE crash course that has been launched only for 23 days. Yes, you have everything here. The teachers have been showed, which teachers will be teaching you. Vipul sir, Ziyad sir, Payal ma'am, they will be teaching you with all the different subjects that you can see. The whole schedule is also out, guys. The whole schedule is out. You can also study from here. Okay, everything is given. So if you want, you can do this, and the coupon code is YT Enlight. Okay, YT Enlight. Enlight is a channel name, YT for YouTube. If you do this, then that's it. You will be able to get into the zone of JEE, and I'm pretty sure that you will be able to completely, kill it. Yes, and you will be able to mark your seat in the JEE exam. And that's all. If you felt like this session was helpful to you, if you are new to the session, then don't forget to subscribe to the channel. And if you have been old, then please don't forget to like the session as well. That will help me. Yeah, Vedantu people will understand that Navamita ma'am teaches well. Otherwise, they will think like, nobody is liking. Why should we keep her here? So don't do that to me. And apart from that, thank you so much. I will see you all next time. Tomorrow, same time, same place, 2 p.m. Tomorrow, we will be doing mole concept, redox reaction, and I think chemical equilibrium, if I'm not wrong. Check out the schedule once again. Yes, and I'll see you. But tomorrow, I want more students to join in. If you like the session, share it with your friends and let them know that I'm taking a session right at this time so that a lot more students can clear their JEE. Okay? Bye-bye. See you next time, guys. See ya.